Hello and welcome to 5-Minute Math. My name is Aaron Dafford and this is a walkthrough of the 2023 8th grade STAAR test. If you want to see the full item analysis report, or at least my version of it, you can grab the QR code on the screen or you can look for a link in the description to the video. You can also fast forward to any particular item that you want to by using the timestamps on the screen or scroll along the bottom of the video. This is the first problem on the 8th grade 2023 STAAR test. We are visualizing real numbers. This is TEKS 8.2a, reporting category 1. So we've got a Venn diagram here, and we just need to figure out where does negative and then square root of 169 go. So the simplest thing for us to do here is to simplify this negative square root of 169, and honestly, the trick, if you want to call one a trick, is to kind of separate this negative and then the square root of 169. So we're going to deal with those two things separately. So if we open up our calculator, what we're going to do is we are going to just take the square root of 169. So we're going to hit that second, right? And then we're going to hit that square root, and then 169. Right, and that's 13. So what we're going to notice is that's going to give us our square root negative 169 is going to give us negative, and then that's going to simplify to 13. We could also do it all together, negative square root of 169, and that's also going to get us negative 13. So either way, we're going to get that negative 13. Then we have to interpret where does that go. All right, so how can we figure that out? Well, let's take a look at our options here. So our natural numbers, right? That's going to be your 1, 2, 3. These are also called your counting numbers. Your whole numbers are just your natural numbers with a 0 there. When we teach kids to count, we don't start with 0, we start with 1. That's why we start with our natural numbers. But whole numbers, right, include 0. Integers are still numbers that are not decimals, but they include negatives. Right, and that's where that's going to go. All of this is going to be this negative 13, this negative 169. It's going to live within that integers right there. Right, rational numbers. You see that word ratio, right? And so that ratio is going to include decimals, right? 4.5. It's going to include improper fractions, things like that. And then your real numbers and irrational numbers, this would be like pi, this would be square root of 2. All right, so we see here that we've got negative 13. And even if we didn't know any of those things, B is the only one that correctly interprets square root of 169, negative square root of 169, as that negative 13, which we see in our calculator here. So our answer is going to be B. Let's see how we did across the state of Texas. This was the easiest problem on the test. They started us out with a real softball here. Over 80% of the students, this is the highest percentage correct we'll see on the test, got this one correct, and a very small smattering got these other ones correct. This 84.5, right, that comes if you take the 169 and you divide it by half. So they just misinterpreted the square root as a divide by 2. And you see this 169, this 13 right here, it just kind of forgot what happens with that negative, and it just kind of dropped that. But really, if you just plug it into your calculator, negative 169, it's going to get you negative 13, and that's the only answer that is the option there. Number 2, we are generalizing transformations. This is TEKS 8.10a, reporting category 3. And we have a trapezoid that is, we don't have a visual representation of it, but it simply states that it is reflected over the x-axis, and it's going to form a new trapezoid. So let's just draw that, right? Let's say we've got a coordinate grid here, and I'm going to just draw a trapezoid. And I want to reflect it over the x-axis, right? So that means we're just going to kind of flip it. It's going to kind of look like this. And then we just need a true statement, okay? So the area of KLMN, so that's my first one, KLMN and then my second one, right, is going to be w, x, y, z. So A is, the area is greater than. No, that would be with a dilation. So if I'm just flipping it over the x-axis, I'm not growing it, I'm not shrinking it. So the area would be equal, not greater than or not less than. The angle measures of trapezoid KLMN are less than. No, even if you were to dilate it, if you grow it or you shrink it, the angle measures stay the same, right? When you're reflecting it, everything stays the same. You're just kind of changing the orientation of it. But the angle measures, even if you dilate it, are going to be equal. C, the sum of the angle measures of trapezoid are twice the sum. Look, it's a trapezoid. What are the sum of any quadrilateral? 360 degrees. I don't care how big it is or how small it is. The angle measures in a quadrilateral, which a trapezoid is, are always going to be 360. So we're not going to double the sum. That's ridiculous. And then the side lengths of trapezoid are congruent. Okay, so we're using vocabulary here. That just means equal. Yeah, the side lengths haven't changed because I didn't dilate it. All I did was flip it, and everything stayed the same in regards to side lengths and angle measures. I just made it orient in a different direction. So that is my answer D. Let's see how we did across the state of Texas. So this was tied for the 6th easiest problem. You see we had 66% of our students get this one correct. Now here's the interesting thing. Our incorrect answers were really kind of focused around B and C, and both of them had to deal with angle measures. So this would let me know that we need to do a little bit more work about looking at transformations and the difference between a dilation versus a rotation, right, a reflection, translation. Because those principles of what happens if we dilate it, grow it, or shrink it, how does that affect the angle measures versus the side lengths? Hopefully our students are understanding that even if we were to dilate it, right, if we were to take this trapezoid and then really just grow it into a much larger trapezoid, the side lengths are going to change, but the angle measures are always going to stay the same. It doesn't matter, the angle measures don't change. So that's a misconception that probably students are getting a little bit tripped up on, and that's what caused some of them to select either B or C. Number 3, we are looking at a readiness standard in reporting category 2. This is identifying functions, TEKS 8.5G. Now this is a multiple select, so I need to select 2 correct answers here. And the key here is that it states that y is a function of x. And when we know that y is a function of x, this is what we need to know that means. That means that each input, or each x, only has one output. And once we have that kind of in our brain, that one output meaning one y, each x only has one y, this becomes very simple, right? So let me scroll this down just a little bit, and we're going to look to see which set of ordered pairs can also belong to the function, and there's going to be 2 options we need to select. Well, take a look at this first one. If I were to just extend this down here and say -4, 3. So let's see, can we do that? Well, take a look at the issue here. I would have a -4 going to a -5, but then that same -4 would go to a 3. So it would fail the vertical line test. So that's why this one is incorrect, because each x can only have one y. So that makes that wrong. So you're looking for the 2 pairs that do not repeat. Look at this next one. I'm going to extend it down here. -2, 3. Once again, I see a -2 right there and a -2 right there. So I can't have -2, 3. And so I've got 4, 3. I don't see a 4, 3 repeating, so that's going to look good. And then I'm going to have a 6, 8. Well, I've got a 6 right here, repeating with a 6 right there, so I can't have that. Then I've got a 9, 8. So if we know that a function means that each x can only have one y, each input only has one output, very simple. So my answers here are going to be the 3rd and the fifth choice. Let's see how we did across the state of Texas. This was the 11th easiest. There are 40 questions here, so this was 29th on the difficulty ranking, but only 58%, so we couldn't even necessarily get 3 out of 5 students to get full credit. This is a 2-point problem, so the full credit gets 2 points. The partial credit means they just got 1 out of those 2 correct. There were 20%. 1 out of every 5 students couldn't get either of these correct. And so we don't know which of the answer selections they chose in regards to these 5 options because it doesn't report that way. But I think the most difficult thing to realize for some of these students is this y is a function of x. If they don't interpret that as each input has 1 output, then really we're just guessing here. So we need to work with our students on what does that mean when it is a function. We're used to the vertical line test. If we graph it, we know that we can draw vertical lines, but how do we recognize a function if it's in a table? And we can do it by either mapping, or we can make sure we match up that each x value only has 1 y value. For number 4, we are modeling the Pythagorean theorem. This is TEKS 8.6e, reporting category 3. So hopefully we see a right triangle here. It might be a little bit hidden. And when we're thinking of the right triangle, we should be thinking in 8th grade that Pythagorean theorem, the a squared plus b squared equals c squared, you see at the very bottom of the screen on your reference materials chart. So it is hidden by these squares, but if we can at least recognize, oh look, there's a right triangle inside there, this becomes a very simple problem. All we need to do here is we need to know what is our a squared, our b squared, and our c squared, right? So if this is our Pythagorean theorem, the only thing that we need to bring with us into this is that this c squared needs to be the hypotenuse. And we need to be able to correctly identify the hypotenuse as the side directly across from the right angle. So this is going to be my c. And then the a and the b are simply going to be my legs, but it doesn't really matter which one is which, right? So we can make that a, we can make that b. And then the reason we have squares is because, right, if that side length is a, then that's also going to be a, and so we can do a times a squared, literally makes a square. This would be b times b, and this would be c times c. So if we could match up square f with this c, then we can come down here. We could take a look at our 4 answer choices, right? And we see that the sum of squares d and square e, right? So that's your a squared plus b squared is equal to the sum of square e, of square f here, and that's your square f is your c squared, okay? We can automatically eliminate a and b simply because they don't even say equal to. They say less than and greater than. And when we're dealing with a Pythagorean theorem, it's equal. So it's not a or b. It's really just between c and d, but look at c. D and f, right? So this would be your a squared plus c squared equals square e. That's equal b squared. And just visually, that doesn't look right because it is easy to kind of see d plus e is going to equal f because f is the largest. So our answer here is D. Let's see how we did across the state of Texas. So this was the 3rd easiest. You see, we had 69% of our students get it correct, almost 70%. But take a look at the number 1 incorrect answer. 17%, almost 20% of the students chose B. Now, why would they choose B? Well, look, square D plus square E square F. That's exactly what we have down here. Square D, square E, square F, right? They know that it's this A squared plus B squared equals C squared. What's the issue? This one says greater, this one says equal. So they were just quickly saying, all right, the 2 smaller ones added together make the larger one, and the only difference was they didn't slow down and read it out in words. And so that would be a little bit of a flag for us to take time to practice. We're used to seeing this in an equation, but now we have to translate this into written form. And when we have to translate that into written form, we're not going to use the equal sign. We're going to say is equal to, right, rather than greater to. So we need to take a little bit of time to work with our students to translate these equations into written form to see how they're written out, because that was a pretty simple flag that they gave us, the greater rather than equal, and it tripped up 17% of our students. For number 5, we are looking at the slope of similar right triangles. This is reporting category 2, TEKS 8.4a, and we get 2 different triangles here, and it says they are similar, right? So that means they are proportional in size. We've got the same angle measures, and you see that we've got a question here about the proportion that represents the slope of the line containing R, S, and T. All right, so we're looking at this particular line right here, right? And we see that RVT, that's the small one, and then RBS, that's the big one, right? And you see that both of the hypotenuses for those 2 right triangles are on that exact same line, so it makes sense. Yeah, sure, it's the same slope because it's part of the same line. But how do we represent that? Well, how do we find the slope? Okay, well, slope is, right, the change in y over the change in x. So let's find the slope of this small one, and let's find, this xy coordinate and this xy coordinate. Okay, so this r right here is going to have an x of negative 11 and a y of 6. That t is going to have an x of negative 9, and then it looks like it's got a y value of 2. Okay, so let's make this x1, y1, x2, y2. So if we just substitute these values, it looks like it's going to be 2 minus 6 over negative 9 minus negative 11. So it's going to be negative 4 over, that ends up being a positive, right? Negative 4 over 2. So it looks like my slope is negative 2, which makes sense. It moves down left to right, so it is going to have a negative slope. And for every 1 movement to the right, it's going to go down 2. So it's going to go down 2 over 1, down 2 over 1. That does match. Well, if it's the same line, then it should be, and I'll stick with blue here, it should be the exact same slope. So I'm going to keep that x, y value there, but let's see what this value is right here. I've got an x of negative 6 and a y of negative 4, and we're going to make that now my x2 and my y2. So let's see what the slope of that larger line is. So my y2 is negative 4, and then my y1 is 6, and then my x2 is negative 6 minus, and my x1 is negative 11. All right, so that's going to be negative 10 over, that's a positive 5. All right, so it does equate negative 2, which it should be. It's the exact same line. Now, there's a chance that what I did is going to show up here, but there's a chance. Take a look at my answer selections. Unless they did the exact same x1 and y1, right, because I could reverse those, I'm not going to be able to find that exact value. So what do I do now? Well, the easiest thing to do is let's just simplify these. Let's see which of these, right? I know my slope is negative 2, so let's just do a little bit of simplification. We get negative 2 on each side. So I've got this 2 negatives, that's going to make it 10 over 2 negatives. That's going to end up being a positive, right? So that's 10 over negative 5. Okay, that makes negative 2. And then this is going to be 4 over, that's going to end up being negative 2. Yep, A looks good. So let's see what this makes right here. This is negative 11 plus 6, that's negative 5 over, that's going to end up being a positive 10. Nope, that's a negative 1/2. So B is not going to work. So this is going to end up being a positive 10 over negative 6. That's going to end up being a positive 6 because I got 2 negatives. It's going to end up being a negative 5. Okay, that could work. But let's see what it looks like over here. I've got, oh, that's interesting. That's going to be negative 5 over 6. No. Okay, C doesn't work either. And then I'm looking at 2 negatives. That makes a positive 10 over And that's going to be a negative 5. Okay, that works. Now I've got a negative 4 over, interesting, that's going to end up being a negative 2. Very close, but that's going to end up being a positive 2. So that's not going to work. So I needed to find the slope and then just simplify all of these here. My answer is going to be A. Let's see how we did across the state of Texas. This was definitely on the more difficult side. This is tied for the 16th most difficult. We only got 41%, a hair over 2/5 of our students got this one correct. Take a look at these two incorrect answer choices, right? 23%, 23%, right? That lets me know that we've got some guessing going on here. And probably this is a little bit lower because we do have a few students that didn't guess but actually worked it out. But that problem in itself required multiple things. First, I had to find the slope of both lines to verify that it was going to be that negative 2. And even if you got that far, there's nothing that says negative 2 about any of those answered choices. Second, I had to calculate and simplify each of these equivalent fractions to see did they equal the negative 2, and you saw how much time that took. So this type of problem definitely requires students to formulate a plan and build up the stamina needed to be able to simplify each of these problems and not just try to eyeball it and just try to take a guess, because there is a lot of simplification going on with all of these expressions, and there's a lot of room for error if they make a mistake on any one of these. So we need to develop a plan and focus on building up the stamina to stick with the problem, even though it does take quite a bit of work. For number 6, we are looking at a readiness standard in reporting category 3. This is dealing with surface area, TEKS 8.7b. So we have a rectangular prism here, and we need to find which rectangular prism has the same total surface area. So we should open up our reference material, take a look at our surface area. We're looking for two things. Number one, total rather than lateral, so that's going to be on the right side, and then prism, not cylinder. So we should be thinking to ourselves, all right, so we need to write this down. This S equals, and then we've got the pH plus 2b. Now we need to interpret that correctly. What is that pH plus 2b? That P is the perimeter of the base, right, times the height. So we still need to interpret this a little bit. Perimeter times the height. And then that 2 is the 2, but the B is the area of the base. Area of the base. All right, so let's put this into an equation for our exemplar up at the very top. So the perimeter of the base, right, is going to be 8, 4, and then 8 and 4, right? So you can take your 8 and 4, that's 12. You can double that to make 24, right? So the surface area is going to equal 24 times the height, which is that 20, plus, and then 2 times the area of the base. That's 8 times 4, right? That is going to be 32. So I'm just going to kind of write that out there. I want to write the equation for each of these, and then we will calculate them kind of all at once. So let's see what A is here. So the perimeter is going to be 3 plus 4 is 17. So we're going to double that. We're going to make that 34, multiplied by the height, 14, plus 2 times the area of the base. That would be 3 times 14, right? And that's going to be 42. And then so this is going to be the perimeter. That's 3 plus 4, 7. We're going to double that to 14 times the height. That's 40, plus 2 times the area of the base. 3 times 4 is 12. Right now we need to do the same thing over here. So we're going to do the S equals. The perimeter is going to be 16 plus 2 is 18. Double that. It's going to be 36 times the height, 10, plus 2 times, and then my base is going to be that 32. That's 16 times 2. And then we've got this last one, right? So we get the perimeter. So 14 plus 4 is 18. Double that, 36. Right, times the height is 12. Plus, we've got 2 times the base. Let's see, 14 times 4, same as 28 times 2, that's 56. All right, we have all of that. Now let's calculate. Let's see what we have here with our calculator. So let's do the original, right? 24 times 20, and then plus 2 times 32. What are we looking for? We're looking for 544. All right, so we're just going to calculate each of these. We've got all the formulas completed here. We're looking for 544. So let's look at A. So I'm looking at 34 times 14 plus 2 times 42, 560. So close, but not quite. Let's look at this B here. So it's 36 times 10 plus 2 times 32, 424. Not really close. Let's look at C. All right, we've got 14 times 40, and then 2 times 12. Add those two together. No, 584. So let's hope it's this last one, D. So we've got the 36 times 12 plus 2 times and then 56. There we go. Right there in front of us. The answer is D, 544. Let's see how we did across the state of Texas. So this was tied for the 18th most difficult question. So kind of in the middle out of a 40-question test, but leaning a little bit more towards the difficult side. You see, we barely got over 2/5 of our students to get this correct. But hopefully from the explanation that I just provided, you can see why some students didn't want to take the time. Take a look at our answer choices. 21, 20, 15. We're kind of hovering around that 25%, that 1/4 that lets us know that we are guessing. In this case, I don't necessarily think that students were confused about how to calculate the total surface area unless they weren't able to equate the items needed on this reference material, right? This equation, unless you really know what the P and the H and the B are, that could be a little bit confusing. You have to know that the P is the perimeter, the H is the height, right? The B is the base, the area of the base. But if they knew what that was, it still takes a lot of work. So step one, let's understand what does that P mean, right? The perimeter of the base, the height is the height of the object, and the B is the area of the base. So these are three things that we need to know what it means. But even if we get to that point, look at all of those equations I had to create and calculate correctly. There's a lot of room for error. So this is one in which we need a lot of practice, A, setting up the equations, and B, inputting them into the calculator correctly. For number 7, we are looking at proportional and non-proportional graphs. This is TEKS 8.5F, reporting category 2. Now there's no graph on this one, but they do want us to find a proportional relationship between x and y. So if we wanted to visualize that, what they're asking for is if we were to graph these points, which of these, assuming it's going to be a positive slope, it could be a negative slope, but which one is going to go through the origin? Because that's what we're looking for. When we have a proportional graph, it goes through the origin of 0, 0. Well, we don't have any graphs here to see. We could plot all of these points if we wanted to and just kind of, they're discrete, so we'd have to look at each point and try to connect the line, or we can know that our slope here, right, is going to be the change in y over change in x, and it needs to be constant. So we could also check the y over x and just see if we have a constant slope here. So let's open up our calculator and we can just calculate the slope of each of these. And so what I want to do is I want to just take each of these values here and I want to take the y value divided by the x value, and we'll just see if we can get something that is constant and consistent here. So let's just open this up a little bit here. Let me go give myself some room. All right, so let's just take like negative 8.5 divided by negative 4.5. And that's going to be, okay, 1.89 repeating, right? So I'll call that 1.8 repeating. Now, I can already tell you, but let's just go ahead and check it out on the calculator. we're going to have something different for the second one, right? And this is not a proportional relationship, because I would need to see the same thing all the way down. So I'm going to go ahead and eliminate A, because it's not the same thing all the way down. All right, let's just check B. So 1.5 divided by negative 4.5. So that's negative 0.3 repeating. All right, so I've got the same thing for the second one, right? That's the same thing, negative 0.3 repeating. Negative 2 divided by 6, yeah, that simplifies to negative 1/3. And let's see that that's negative 3.5 divided by 10.5. All right, that looks proportional. B's looking good. Let's just verify that it's not going to work for C or D. So negative 14 divided by 3, negative 4.6 repeating, negative 4 2/3, negative 9.5 divided by negative 1.5. That's going to be, let's see if I can get that back there, negative 1.5. Yeah, that's a positive. I forgot to add that negative for the 3, but it doesn't matter. This is 6.3 repeating. That's not going to work. And you know what? Just visually save ourselves the trouble, right? This is going to be negative 4/3, so that's going to be 4/3. But look at this. This is negative 6/3. That's going to be a positive 2. This is going to be positive 4/3. I can already tell you they're different. So that's what we're looking for. We're looking for a proportional relationship that has a constant, steady rate. The only one that does that is going to be B, and that is our answer. Let's see how we did across the state of Texas. So this was the 13th most difficult, actually tied for the 13th. You see, we only got 40% of our students, 2 out of every 5. Because there's not a lot of data to go on here. So the 2 out of 5 students that were able to answer this correctly show that we really struggle to understand what does it mean to have a proportional relationship, right? And that ratio, understanding that ratio of y over x is one way to describe that proportional relationship. Because you see we've got 23%, 23%. This definitely makes me feel like this was a problem that ended up with a lot of guessing. And this 14% is a little bit lower because there were a few kids that figured out what to do, and they transferred some of their answers over to B rather than just randomly guessing. So this lets me know that we need to work on not only showing proportional relationships that are linear on a graph, but also what do they look like on a table. For number 8, we are looking at transformations on the coordinate plane. This is a readiness standard in reporting category 3, TEKS 8.10c. But there is no coordinate plane for us. We just have to show you the mathematical representation here, or the rule, to describe this transformation. So let's visualize it. So let's say that we've got a coordinate plane. We don't necessarily need to plot it because they don't give us any x or y coordinates. So let's just say we're going to make our coordinate plane right here. And let's put our rectangle right there. And this is going to be M, N, P, Q. So it's going to be translated. So we need to know what this word means, right? This is a slide. It's going to maintain congruence. It's not a dilation. Dilation grows and shrinks. So the translation is going to slide it 4 units to the left. Okay, so we're going to move over 4 units to the left, which means we're getting smaller, which means we need to subtract 4. So we need to have 4 units going away there, and then 3 units up. So we would slide it vertically 3, which means we're going to add 3. So how are we going to represent this rule? Well, we're not going to multiply, okay? These right here that I'm crossing off, these are dilations. So we're not going to dilate it by making it larger or by making it smaller. We're going to move our x, because this is the x, right? We're going to move it 4 to the left, so that's going to be x minus 4. So let's grab that in there. And then we are going to go 3 units up, but this is the y. So we are going to say y is going to go up 3, so that's going to be this right there. And that's how we would answer this question. Let's see how we did across the state of Texas. So this tended to be on the easier side. This was the 11th easiest problem. Now, we don't know which incorrect answers our students chose. That's not how it's reported to us, but we know that 59% of our students, almost 60%, got full credit. That means they got both points correct. This is a 2-point problem. And if you add that together with the partial credit, so that's just 1 out of 2, that's almost 80% of our students that got at least 1 point. So the difficult thing here most likely is, and I guess we could have some students that selected these, right? So that's the -4 that we were looking for, and it is the +3 we're looking for, and they are with the x and the y. The issue there would be that those does not show a translation. That's more of a dilation. So we need to practice not just the visual representation, but practice writing the rule to describe transformations. And then other than that, there's just a lot there. I've got an x plus 3, right? I've got an x plus 4 and x minus 4. So I've got 3 different x's to choose from, even if I get rid of this one. Same with the y. Y minus 3, y plus 3, y minus 4. So that's 8 different choices to choose from. And that's where it can be a little bit overwhelming. And so students need to take an extra moment just to organize their thoughts and handwrite it before they just try to eyeball it and move it in there, because there's a lot of room for error if they do that. For number 9, we are approximating square roots. This is TEKS 8.2b in reporting category 1. Now, this would be easy if they simply gave you the square root and they said, what is the approximate square root of that 182? Well, that's pretty simple because we're just going to end up putting that into the calculator. But they don't give it to you just like this, right? That's a little bit simple. They have the area of a square wall, so now we have to visualize a square wall. They give it to you as 182 square feet. And then we want the measurement that's closest to the side length. So this is what we have to know, and this is not in our reference materials, right? The area of a square is going to be side times side, or side squared. So if we want to isolate for that side, right, we need to take the square root of both sides, and that's just going to be the square root of a equals the side length. So there is a little bit of work that we need to do to realize, okay, I'm going to have to take the square root of 182. But once we do that, right, let's just plug that into the calculator. We can manually do it if we want to, but let's just take our 182. We're going to hit that second to get that square root, 182. All right, we got 13.49, almost 13.5, and we see that 13.5 right there, so it's about 13.49, and our answer here is going to be B. Let's see how we did across the state of Texas. This one was tied for the 13th most difficult. You see that we only got 2 out of every 5 students to get this correct. The issue came with setting it up. How do you recognize that if you have the area of a square, that's 182, the side length, right, is going to be the square root? Well, we have to recognize that area, the relationship between the area and the square root. So not many people chose 9, right? That would have been a little bit strange. You actually have to take the square root of 182 to get about that 13.5 and then multiply it by 4 as if they're asking for the perimeter. If they chose the 91, they just took the 182 and they just cut it in half. So maybe they evaluated it and said, okay, we do need to take the square root, but they thought that's dividing by 2. Maybe so we need to do a little bit of work on what does it mean to take the square root. And this is that 45.5, right? This is the 182. And you divide it by 4 as if maybe they were thinking perimeter. And they were thinking, all right, it's a square, 4 equal sides. I need to take my 182 and divide it by 4. So maybe we had an issue of understanding what that word area meant rather than perimeter. So a lot of areas to clean up here when only 40% of our students could get this one right. So for number 10, we are looking at one variable equations. This is a readiness standard in reporting category 2. Takes 8.8C. And so we've got these algebra tiles here, and we need to first turn them into a workable equation. And so let's do that, because then once we can do that, we can solve for x. So I've got 3 negative x's. So first I need to see this as negative 3x, because there's 3 of them. And these are 4 ones, so I'm going to add 4. So step 1 is turn this section into negative 3x plus 4. Now I've got negative 2x's, and I've got a positive 1 right here. So this is the difficult part to begin with, is at least just setting this up. Now we need to solve for x. We've got a few choices, but I want my x to be positive. And so I've got 2 negative x's. So I'm going to add a 3x on each side. I can keep a balanced equation if I do the same thing on both sides. And if I do that, that's going to eliminate the x over on the left. That's going to leave me with positive 4. 3x minus 2x, or negative 2x plus 3x, that's just going to give me an x plus 1. Now I need to subtract 1 from both sides to eliminate that, and that's going to give me an x equals 3. So my answer here is A. And let's see how we did across the state of Texas. So we have the 12th most difficult problem here, and we have almost 40%, not quite, getting our number correct here as 3. Now, what's interesting here is, take a look, we've got a 3 as the correct answer, but we almost have the same amount of students choosing the incorrect answer of negative 3. And so you saw there that we did have an opportunity to kind of get confused. So let's say we set this up correctly, right? Negative 3x plus 4 equals negative 2x plus 1. Now, in the explanation, I went ahead and added 3x to both sides. But let's say we don't do that. Let's say we just add 2x to both sides, because you think I need to move the x to the left because x has to be on the left. All right, let's do that. That eliminates this, right? So what you're going to end up getting here is you're going to get a 1 over here. You're going to get a negative x, right, plus 4. And then if you subtract 4 from both sides to eliminate that, you end up getting a negative x equals negative 3. You see what this negative 3 is? Now I went ahead and eliminated that issue by making my x positive, but in order to do this right, now you've got to multiply both sides by a negative 1, or divide both sides by negative 1. It doesn't make any difference, to make your x positive. So I see a big chunk of our students maybe doing all the work correctly, and then they end up with a negative x. And so there's a little bit of work for us to do as educators to help our kids know, you know what, we're not going to end up with a negative x. That's not what we're looking for. We're looking for positive x. So we always need to multiply by negative 1 or divide by negative 1, whichever one you want to do, in order to make that x into a positive x. For number 11, we are looking at dilations. This is TEKS 8.3b in reporting category 3. So we have this quadrilateral LMPQ, and it's going to be dilated to create LMPQ prime. And all we know there is we've got this rule. And so I'm going to scroll this down a little bit, but I want to see that rule here. And it's that each x and y is going to be multiplied by 3.75. So there's my rule. So what does that mean, right? So I've got this of 6, right? This has an x of 6, a y of 2. I'm going to multiply each of those by 3.75. So my new x and my new y, right, are going to be way out here. And then q, right, is going to be way out here. L is going to be way out here. And then m, right, is going to be way out there. So I'm going to get a much larger quadrilateral that kind of looks like this. So if that's what my new quadrilateral, the LMPQ prime, looks like, well, now I need to try to figure out what does that mean in regards to the dilation. So first thing that we need to see here is when we get larger like that, we're not changing the angle measure, okay? We're not changing the angle measure. The angles stay the same when you dilate. It's the side lengths that get larger or get smaller, but the angle measure is exactly the same. So we're not even going to look at A or B. Let's look at C or D, right? And you see it's 3.75. Everything is 3.75. So the trick here is, are we looking at the angle measure or the side length? We're not looking at the angle measure. What we did is we increased the side length. But take a look at this. 3.75 times, that's what I did, 3.75 more. That means it's going to be x plus 3.75 and then y plus 3.75. That's what that 3.75 more means. And that's not what we're looking for. We're wanting to multiply it, right? It's 3.75 times x, 3.75 times y, which is the rule they gave us at the very top. That's what that C is. So C is our correct answer, but let's see how we did across the state of Texas. So this was tied for the 16th most difficult. You see we barely had more than 40%, or 2 out of every 5 students actually get this correct. And as always, we look at how were the incorrect answer selections distributed, and we see that we've got pretty good sign that we have a lot of guessing going on here. So we've got almost 25% on A and B, a little bit lower on 13. That means some students were actually getting it right. Now, there's not a lot of clues here if you didn't draw that picture of that much larger dilation, right? Everything here says 3.75. So that is the only number that's actually in the problem, right? That 3.75, they give you that rule up there. So you can't eliminate an answer because they don't say 3.75, right? And it's just a lot of words rather than mathematical expressions. And so sometimes just reading all of this, the only differences are right here, and I'm going to go ahead and underline them in blue. Angle, angle, side length, side length. And then I've got the times, more, times, more. So if you're just skimming this, it looks like all 4 of these answer selections are basically the same thing, so I'm just going to guess at them. So this would be an opportunity to work with students as to first visualize what a dilation means, right? And are we going to grow it or are we going to shrink it, right? And we got that word dilated right there, which means we should know that we're going to grow or shrink. That 3.75, that's greater than 1, right? That lets us know that it's going to grow. And that means, first off, we should be able to eliminate angle measures because dilation does not change the angle measure, it does change the side length. Now this was a little bit tricky here, the times versus the more, but even if we could eliminate A and B, that would have given us a 50% chance if we weren't sure of the difference between times and more. For number 12, we are looking at trend lines. This is TEKS 8.5D, a readiness standard in reporting category 4. So we have some iced tea sales, and we have a scatter plot here. We're looking for that gap. You notice that gap right there at 80. And so we are looking to see which number best fits that line right there. And honestly, the best thing to do is for us to draw a straight line. And let's look to see if we can use our graph paper feature here. I'm going to change the grid size to small, right? And so what I can do here is I can add a point to where I kind of think it's going, but let's draw a line. And I'm going to go in between those 2 dots right there. I'm going to kind of go right on that dot, in between those 2 dots, on that dot. And that's kind of how we draw trend lines, is we try to go in between 2 that happen to be there, and then right on 1 if it seems to be right in the middle. So something kind of like that seems to be fitting the data that we have. So let me increase the transparency so we don't see it anymore. I'm going to add a point, and right there it looks like it's going to be right around, well, the dot was on the 56. I'm thinking it's a little bit less than the 56. I'm thinking it's more like maybe 55 or 54. So we'll go with that 54. It's my best guess. Realize we're looking at the 80, not the 72. And let's see what we have here. Our answer choices are going to be, let me write them over here so I can get that graph back on there. 53, 62, 40, and 30. All right, so that was what I ended up drawing right there. And take a look at these dots, right? So 53 is kind of right where I was. Put that right there. All right. That 62 is going to be way up there. 40 is going to be right around there, and 30 is going to be a little bit above that line. So nothing really fits except for that 54, which they're calling a 53. So that is my answer A. Let's see how we did across the state of Texas. So as you can guess, this was pretty easy. This was actually the second easiest question on the entire test. 72% of the students got that correct. They were able to eyeball that. That 62, right, that one obviously was a little bit too high. So we had 17% of our students getting that. Not sure why they would see that 62 unless they really weren't looking at the 80. Right? That 62 kind of makes sense if you were looking at like an 84 or something like that. So maybe they were just off a little bit, but 72% of our students got that. They probably drew the line, and they were able to get the 80 line rather than that 72 because there were two different blanks there, and it looks like they weren't really tripped up by that. For number 13, we are looking at intersecting linear equations. This is TEKS 8.9a in reporting category 2. We've got two lines graphed on a coordinate grid. We need the ordered pair that is the solution. Now, we don't need to make this overly complicated. If we could recognize that a solution needs to be a point that happens to be on both lines. I've got one line right here. I've got one line right here. What is the one spot that is on both lines? Well, it's the intersection. Okay? So the solution is the intersection of two graphed lines. And so now we simply need to graph that. It's got an x-coordinate of 4, a y-coordinate of 5. We don't need to overly complicate it. So the answer is D. Let's see how the students did across the state of Texas. So this was tied for the 17th easiest. There's only 40 problems, so this was right in the middle of the pack. Barely more than half the students were able to get this correct. So what were these other answer selections that kind of tripped us up? Well, you know the answer was 4, 5. What happens if you reverse the x and the y coordinates? You do all the work and you end up reversing the coordinates. That's what you're going to get is A, right? You can get B here two different ways, right? You just select a coordinate that's on the graph, or possibly you're looking for a y-intercept. That's what B is. And then this 8, 3 is just, we're just guessing. We've got 4 different coordinates, right, that are named for us on the graph. We don't know what the intersection means, so we simply just grab any number that we see in front of us, which should give us a warning sign like that looks too easy. So the solution, what do we need to work on with students? The solution is the intersection. Because if we can help them see that connection, that when we solve two linear equations, we're actually going to find a place where they meet so we could graph them and find the intersection, this becomes very simple. So number 14, we are looking at volume. This is a readiness standard, TEKS 8.7a in reporting category 3. We have a shape here for us, and we need to find the measurement closest to the volume of that shape. So first thing we need to do is we are going to need our calculator. Let's get that out. Lots of calculations happening, but we also need to go ahead and decompose that shape. So that's actually going to be easiest for us to look at if we cut this into two shapes, right? So we've got this half of a sphere, right? So we can call this a hemisphere, and it's sitting right on top of a cylinder. So let's deal with both of those volumes separately, add them together at the end. All right. Then I guess before we get started too much, right, we need to go ahead and let's get our reference materials out, at least get the correct formulas down for our volume, and then we'll close that back up. All right. So what are we going to need for our hemisphere? Well, we don't have the hemisphere volume, but what we do have is a sphere. Okay, so I'm going to say V equals that 4/3 pi r cubed, and the hemisphere is really half of it. So I could take all that and divide it by 2. We'll come back to that. There's a simpler way to look at it, but really it's a half a sphere. So take the volume, cut it in half, right? So we got our cylinder, right? And our volume is going to be, okay, it's very simple, base times height, but we need to know that the base is the area of the base, and that area of that base is a circle, so that's pi r squared. So I'm going to simplify, substitute in that b for pi r squared because it's the area of the base. So really it's going to be pi r squared times the height. All right. So now that we have that, let's take a look at, let's get our calculator back out. All right. So how are we going to attack this? Well, let's start with the cylinder first because that's going to be pretty simple, right? We've got pi, and we've got the radius, and they give us the radius right here as 3. So that's going to be pi and then 3 squared, and then times the height, which is going to be 7. Okay, we can actually simplify that, right? That's going to be pi times 3 squared is 9 times 7. So really, that's just 63 pi. Okay, so I'm going to put this as 63 pi. That's pretty simple. Now let's deal with that hemisphere. Okay, so we could take all the volume and we could divide it by 2. But we should also know that dividing it by 2 is the same as multiplying it by 1/2, right? You can divide by 2 or you can multiply it by the reciprocal. So instead of this, let's multiply all of this by 1/2. So what I want to do is I want to take that 4/3 and I want to multiply it by 1/2 because I want to do it all at once. So 4/3 by 1/2, right? That's going to end up being 4/6. We multiply straight across. So that simplifies to 2/3. And that makes sense. Half of 4/3 is going to be 2/3, right? Because 2/3 plus 2/3 equals that 4/3. Okay. So we're going to say it's 2/3 pi, and then that radius is 3. Okay, so 3 squared. Or 3 cubed, excuse me. So 3 cubed is 3 times 3 times 3. So that's going to be 27. Okay, so we can say that's going to be 2/3 times 27, right? Times pi. We can even simplify that, right? That goes there 1, and that can go there 9 times. So now it's going to be 18 pi. All right, so look, we've got 18 pi, and we have 63 pi. All we have to do is add those together. All right, so we've got 18, and then let's grab my pi, so that's going to be the second, and then that caret, plus 63, and then times that pi. We've got that 254.469, right? And look at that. We've got that sitting right there at C. So that is our answer. Let's see how we did across the state of Texas. This was tied for the 4th most difficult problem on the entire test. As you can see, we didn't even get the correct answer C as the most chosen. It actually was this B, this 38% was actually chosen more than that C, 29%. So what made this the 4th most difficult problem, or at least tied for it? Well, remember our hemisphere basically came down to 18 pi. And we had our cylinder came down to 63 pi. Well, let's calculate where these numbers come from, because A, B, and D don't just come from the middle of nowhere, okay? So what they did here was they assumed students were going to get all the calculations correct, but instead of adding these two, they ended up subtracting these two, right? So we've got the 63 pi minus the 18 pi. Rather than adding those two, they subtracted those two, and that gets your 141. Now, how do you get this 197? Well, this is simply 63 pi. This is what you get if you calculate just the volume of the cylinder and you don't have anything to do with that hemisphere. Now, how can you get bigger than our actual answer of C? Well, remember this hemisphere, right? It was the 4/3 pi r cubed, and then we had to multiply the whole thing by 1/2 because it was half of a sphere. Well, what this is this is just the volume of an entire sphere. So what if students calculated the volume of an entire sphere? Well, we wouldn't have cut that in half, so really it would have been 36. If it was an entire sphere, we wouldn't have cut it in half. It would have been 36 pi, right? So that's what this is. That's this 36 pi plus the 63 pi. And that's your 311. So this is a difficult problem. Multiple things need to happen here. First, probably the most difficult was to decompose the shape into two shapes and identify this one up at the top as a hemisphere. And identify and say, the closest thing I have is a sphere, and I either need to divide that by 2 or multiply that by 1/2. If we can identify that, the rest becomes calculations and simplifying. But really working on these shapes that aren't just a pyramid or a prism or a cube, but composite shapes with half of a something, that's going to be a good challenge for our students. For number 15, we are practicing the concept of saving for college. Reporting category 4, TEKS 8.12G. And you notice we have drag and drop, right? And so each answer can only be used once, but we need to fill in both answers there. There's 5 to choose from. So we are saving for college, and let's see what that does for us. So Desmond wants to attend college, right? He's got $15,000 for the first year. Desmond's family's already saved $6,000. Okay, so that's going to be big. So let's just go ahead and take out that $6,000. So that $15,000, right, that's going to be my total cost. But we've already saved that $6,000, right? So let's go ahead and just subtract that. So if we save the $6,000, then we'll call that $9,000 remaining. All right, that's our subtotal. Now, he applied for $1,500 scholarship. To have the full amount needed to pay for next year's tuition, need to set a fixed amount each month. So fixed amount each month for 12 months. All right, so we're looking for a constant rate. And so how much money should they save for the next 12 months to have enough for college? And then there's two options, with the scholarship and without the scholarship. Okay, so right here, this is my without the scholarship. I've got $9,000 that we've got to get Desmond ready for. If I have the scholarship, right, that's $1,500. Let's subtract that as well. So, okay, $1,500 scholarship, right? That's going to get me $7,500 left. That's not bad, right? That's basically cut his college in half. So this is with a scholarship. Now, we don't have $9,000. We don't have $7,500. We don't have $1,500, right? None of those options are there because, remember, we need to set it aside for the next 12 months, right? So let's get the calculator out. Let's see what we're going to do here. So if I'm going to, without my scholarship, I've got $9,000, right? So I'm going to take my $9,000, just going to divide that by 12. And that's going to get me my total for without, okay, $750 a month, right? That will be without the scholarship. So that is going to be in that bottom section. Does not win the scholarship, $750. And then we've got $7,500 if he does win the scholarship. Let's see what that's going to be. It's going to be less. It's going to be $625. All right. So that $625, if he does win the scholarship, it's going to go right there. So let's get those two answers there. That's $625, $750. Let's see how we did across the state of Texas. So this was tied for the 18th most difficult problem, so right in the middle. And as you can see, there wasn't a lot of hard calculations there. My guess is that we had, look at this, almost 40% of our students get no credit. This is a 2-point problem. You would get no credit if you swap these. If you put your 750 right here, and you put your 625 right here, you would get no credit. And that's almost the amount of students that got full credit. And I'm guessing a lot of our students did that because as I was calculating, right, we had the 15,000, right, we took away the 6,000, that gave us the 9,000. So if you take your 9,000 and you divide that by 12, right, you get your 750. And you're like, oh, good, I see 750. And you put that right here. But that's actually not what is being asked there. That's if you win this scholarship. I had to take away that extra $1,500 to get that scholarship. So I guess some of our students probably put these in the wrong spot simply because they weren't reading closely enough. Because the does not win the scholarship, that's our first calculation, that's where the 750 goes. So this is an opportunity to help our students to slow down, read the problem in its entirety to make sure you know where the answer needs to go. For number 16, we are looking at slope as unit rate. This is a readiness standard in reporting category 2. It takes 8.4b. So we've got these 4 different graphs, and what we're dealing with here is we have a bookshelf containing 15 books that have the same width, right? So we have a constant rate there. The combined width for all is 15 books is 12 inches, and we need to find a graph that has that same slope. All right, so take a look at our graphs here. We've got number of books as our x-axis, right? Total width is our y-axis, okay? So our width is our y, and our books, right, that's our x. Now, why did I put it like this? Well, we know that if we want to find the slope, right, slope of a line is that third one right there. It's that m, it's the change in y over the change in x, the rise over run. So I'm going to put my width over my books because that's my y over my x. So that's going to be my change in y over my change in x. So what do they give me? They give me 15 books. So you notice how they flipped it on us, right? 15 books. That's actually going to be our x value, so I'm going to put that down here. And then inches, that's our width. That's going to be second. That actually goes as our numerator. Okay? So once we get the 12/15ths, right, I can't necessarily graph that because I don't have an x value that goes to 15, right? Like if I'm looking right here, it would kind of be off, and this would kind of be off for that 12 and 15. So it's not as simple as that, but I can simplify this, right? Let's divide both of those by 3, right? And you're going to get 4/5. Okay, so I can graph that because that 4/5, right, that is going to be a y value of 4, an x value of 5. Okay, so let's find a graph that has that. All right, so we're going to look here, and I'm looking for an x of 5 and a y of 4, and I'm not seeing it on that graph right there. X of 5, y of 4. I do see it on B. X of 5, y of 4. I don't see it on C, and I definitely don't see it on D, right? That's just a straight line. So it looks like B, right? And if we want, we can continue it, right? X of 5 is going to be 1, 2, 3, 4, 5 over and up 1, 2, 3, 4. That is my next point. So my answer here is B. Let's see how we did across the state of Texas. So this was the 11th most difficult, right? We did get 38% of our students getting it right, but look, we almost had an equal amount getting that A right. So remember our slope here for this particular problem was 4/5, right? Which means we had an x of 5, right? A y of 4, because remember it is the change in y over the change in x, right? That's kind of the confusing thing. Well, A is going to be the reciprocal of that, right? It's going to say they thought the slope was 5/4. And so if you wanted to graph that real quick, you would see we've got an x of 4 and a y of 5. So you can tell that they were doing the work, and they instead simplified 15 over 12 rather than 12 over 15. So that means that we need to do a little bit more work of understanding that the slope is the change in y over the change in x, and it needs to be in that order specifically. So we need to identify the width and the books obviously were our x values and the width was our y values, which means that width needs to be in the numerator and the books need to be in the denominator. So you knew they would give you the reciprocal as one of the answers, and that got almost as many students to select it as the correct answer. So that gives us a little bit of operating room to make this type of problem more accessible to students by giving them what they did here, giving them the items in the reverse order, right? They gave you the 15 over 12. If you look at that just like that, it looks like it's 15 over 12. And then realizing that's not actually how we need to set this up. We need to flip that because we need to have the change in y over the change in x. For number 17, we are looking at calculating interest. This is a readiness standard in reporting category 4, TEKS 8.12D. And we need our reference material here because it's talking about interest. It says a business owner invested, we've got a principal of $10,500, right? And it's going to pay 1.2% annual simple interest, no additional deposits or withdrawals. So we need the amount that's closest to the interest earned at the end of 4 years. So let's get that information here. Right? So we have a principal, we'll call that P, equals that 10,500. Right? The interest rate is going to be 1.2%. The time, they say, is 4 years. If we scroll all the way down to the bottom, we will see simple interest, different than compound. And that's all we need. We need the interest equals, right, the P and the R and the T. And I label this I, but this is really the interest rate. We can go ahead and call that the R. So that's all we need. One thing we need to go ahead and adjust is this is a percent. In order to multiply it, let's go ahead and make that a decimal. So we're going to divide it by 100 or move the decimal over twice. So it's going to be 0.012%. And we're just going to multiply those three amounts. 10,500 times that percent of 0.012 and times that by 4. And that is going to give us our interest rate. If we wanted the amount that would be left over, we'd have to add that principal back in, but they don't need that. So let's plug that into the calculator. So we get 10,500 times 4 times that 0.012, and we get $504, and that's our answer A. Let's see how we did across the state of Texas. So this is the 7th easiest. It's a pretty simple formula that I equals PRT. Now, 64% of our students got it right. How did we get some of these incorrect answers? Well, I told you it's just looking for the interest. But if you take the principal and you add that interest and you want to see, well, how much money do you actually have in the account now? You will get this B answer, this 1104. So students that chose that need to read carefully and realize they don't need the total amount, they just need the interest. And this would be if T equals 1 year. So instead of the 4 years, C is how much interest there is in 1 year. And then D is the principal plus that to get your total amount in D. So there are a few ways to make some mistakes there, but our answer is A, and we did pretty well on that, 64%. For number 18, we are looking at TEKS 8.2D. This is asking us to order numbers, a readiness standard in reporting category 1. We have a hot spot here, so we need at least 3 answers. And if we try to just answer 2, it will give us this error message. And it is impossible to answer more than 3. So they really want us to answer all 3. So what do we need here? We need to find some numbers here that make this inequality true. So let's just go ahead and We're going to open that up. We're going to open up our calculator as well because we will need that. So let's figure out, something needs to be greater than 28.5 or 28 over 5. What is that? Okay, that's 5.6. So if I want to kind of make an open number line here, and I'm going to make my 28 fifths, I just want to put everything into decimals. It's going to be a little bit easier for me. I need 3 answers that are greater than that, so that means I need stuff that's over on the right side. So let's just start using a calculator. So let's square root. That's the second and then the x squared. Let's get that 34. And that's 5.8. That looks good. So we're going to say 5.83 square root of 34. So we will select that one. I can already tell you that 4.7 is not going to be enough. It is too small. Negative, I mean, look at negative 8, right? So that's an X on that one. Look at this negative 8. This is a positive 5.6, so negative 8 is going to be way over here, maybe even farther than that if we're wanting to make it proportional. And then, look, I could tell you this 5.28, I don't even need to calculate it. That's going to be a little bit too small because we need something that's greater than 5.6. So I'm thinking it's going to be that 2 and square root of 11. At least I hope so, because there needs to be 3 answers. There we go, 6.63, 2 square root of 11, and then 19 thirds. Should be pretty easy to calculate. 6.33. All right, so 6.33, 19 thirds. All right, so I need these two. This is a 2-point problem. You get both points if you get all 3 of these correct, and 1 point if you get 2 of these correct. So let's see how we did across the state of Texas. So this was tied for the 6th easiest, and it really just involved us using the calculator. So you saw that 66% of the students got full credit. That means they get 2 points. And then this partial credit, you have to get 2 out of 3 correct. They only got a little bit less than 20%. But if you put those two together, right, you're looking at almost 85% of the students getting 2 or 1 points correct. So that's not bad. This is typically these hot spots can be a little bit more difficult, but this particular one was pretty easy because we just needed to identify what that decimal equaled and then turn all of these into decimals to compare. For number 19, we are looking at dilation representations. This is a readiness standard in reporting category 3. TEKS 8.3c. So we have a rectangle that is supposedly graphed, but we don't have a visual representation of it. And so let's first draw a picture of this. We don't need to graph it totally. We can just kind of eyeball it here. Right, and so we've got the vertices of the original rectangle, and you see that we've got, you know, 1 in each quadrant, right? So I'm just going to do this. All right, so let's say this is my original. We'll just say those are the 4 points right here. Now, I've got a dilated rectangle, and you notice that it's a little bit inside, right? Instead of 12, 9, it's going to be 8, 6, right? So that's going to be a little bit in, and then 8, negative 6, right? So it's going to be a little bit in and a little bit in. All right, so that's my new rectangle, and it's dilated and it's shrunk in size, whereas the original here, right, is much larger. So what is the rule? Okay, so this XY right here is the original, and the dilated rectangle, that's supposed to be this part over here. So what happened? Well, the X's and the Y's shrunk. So there's a few different ways we can look at this. First, we can look at our answer selections, and we can look to see, well, which of these would make it shrink. Well, if you multiplied it by this 3 halves here, it's actually going to make it increase since that's greater than 1. So it's going to increase it. Multiplying by 2/3, that is smaller, so that could work. I guess we could subtract if we wanted to. So maybe C, and then D has got a plus and a minus. That's not going to work. So we could just initially say, all right, so it could be B or C. But you know what? If we were to move this C and we would look at the original right here. So I'll go to this original, and it would be minus 4 and then down 3. So it would go over 4 and then down 3. It would stay the exact same size, right? It would just be in a different position. This is more of what we would call a translation or a slide. So really the only one that's going to work is that b, and that's going to make it smaller. Another way to look at it would be you can make a ratio, right? So what is the dilated x-coordinate? 8. What is the original x-coordinate? 12. Make it a ratio. Guess what that makes? 2/3. You could do the same thing with the y-coordinate, right? Dilated y-coordinate is -6. The original y-coordinate is -9. Also goes to 2/3. So that is our answer B. Let's see how we did across the state of Texas. So this was tied for the 20th most difficult on a 40-question test. This is right in the middle. You see that we could not even get half of our students to get this correct. And really, I think the lack of a visual representation made it difficult. Unless you kind of drew something or tried to plot it on your own, you might not necessarily see that it got smaller from the original to the dilated. Hopefully, we were able to understand that when we see that term dilated, that means it's increasing or shrinking in size. It's getting bigger or smaller. It's not a transformation that's like a translation or a rotation or a reflection. Now you notice that the most incorrect answer was this C, so at least students were trying, right, to make this a little bit smaller, right, like 12 minus 4 gets you 8, 9 minus 3 gets you 6. I get that, but it doesn't work for this one right here, right? -9 minus 3 would actually equal -12, so it doesn't even work when you're dealing with negatives. And also this would be a slide. This isn't shrinking it. So the key here is to focus on what does this word dilation mean. It means that we're going to multiply by something, so either that A or B, to increase it or to shrink it in size. And all we have to do is realize it's getting smaller, right? Because our x and y coordinate are coming in closer to the origin, so we would need B. For number 20, we are looking at TEKS 8.5i, Modeling Slope-Intercept Form. This is a readiness standard in reporting category 2. We need to graph a linear function. They give us a graph here, and it's going to go through 2 points. We need to find an equation that best represents this function. And as you can see, everything needs to be in that slope-intercept form. So let's go ahead and use the graph that they gave us. Since they went to all that trouble, let's just go ahead and plot these points here. So I've got -2 and 70, right? So that's going to be right up here. And then I've got 6 and -50, so 6 and then all the way down here. All right, so we've got a line that's going to go something kind of like this. I know it's linear, and I know 2 points, so I could draw an approximation there. But really what I'm looking for is my y equals mx plus b. I'm thinking my b is 40-ish, but obviously I'm not going to rely on my drawing to get that. So first let's get our m, our slope, right? So that's going to be the change in y over the change in x. And so if you need that, that's on your reference materials. That's that third equation from the top. M equals change in y over change in x, the rise over run. So let's just make this our x1 and our y1. And let's make this our x2 and our y2. So it's going to be our y2, -50, minus y1, 70. And then that's going to be our x2, 6, minus our x1, -2. So it looks like -120, that's going to be a positive since there's 2 negatives, 8, so -15. All right, so if we're looking at our options, I see C and D are both good options there. All right, so now let's take a look at our B. Now, I said it's going to be 40-ish, so obviously D looks a lot better than C, but you know, let's go ahead and just do it accurately. So what we need to do is we need to grab one of these points and just plug them in, right? So into our slope-intercept form. So my y is going to be 70, We just figured out our m is negative 15. Our x is going to be that negative 2 plus b, and then I can simplify and solve for b. So 70 equals negative 15 times negative 2, 30 plus b. Using the properties of operations, we're going to subtract 30 from both sides. So it is 40. All right, so it's y equals mx plus b. My m is negative 15. My b is going to be that 40. And our answer here is going to be D. Let's see how we did across the state of Texas. So this was the 9th most difficult problem. And as you can see, look at our answer distribution here. This looks an awful lot like students were just basically guessing, and then a few students were actually working out and finding that correct answer of D, so it wasn't 100% guessing. Now, what makes this so difficult? Well, you saw all the work I had to do. I had to take 2 points, right? And I had to first turn that into my slope, and then I had to use those one of those sets of points and the slope to find my B. So that did take multiple steps. There's obviously opportunities for error. And also look at the scale here. Did you notice that my y-axis counted by tens? My x-axis counted by ones. That's where this negative 3/2 comes in. Because if I just do my rise over run, right, this is going to be 1, 2, 3, 4, 5, 6, 7, and then an extra 5 steps. So that's a minus 12 steps, right? And then I'm going to get from, negative 2 to 8. That is still going to be 8. So that negative 12/8 reduces to negative 3/2. The problem is that's not negative 12. These are steps of 10. So that's negative 120, right? That's where the negative 15 comes in. But that's where this comes in. So some students didn't quite notice that the scale in the y-axis was different than the scale of the x-axis, and that's where that 4 comes in as well, right? I told you that my y-intercept was, 40-ish, but if I didn't necessarily notice that the 40 was actually a 40, this is just 1, 2, 3, 4 steps above 0. They just happen to be steps of 10. So that's where that 4 comes in. So students need lots of practice going through these steps here, because you didn't even really need the graph. Taking 2 points, using that to first find the slope, and then using that information, substituting one of the points in to find the b to write the full slope-intercept form. For number 21, we are looking at transformations on the coordinate plane. This is another readiness standard, reporting category 3, TEKS 8.10c. So we've got a square shown on the coordinate grid, and you notice it has the center as the origin there, so it's very symmetrical. And we need to find a transformation that does not produce a square with vertices at the same set. So we have a whole bunch of rules down here, and if you have the rules memorized, maybe this is super easy, but most students don't have all of the transformation rules memorized. So if you didn't have a coordinate plane, I would suggest drawing one or using this graph paper feature to make your own coordinate plane, but they've given you one, so let's use that. And let's just see which one does not produce a square with vertices at the same set. All right, so I'm just going to start with this 2, 2, right? And then I'll do this 2, negative 2. We'll see where those two end up. That'll give me a good idea of what's actually happening here. So I'm going to take this xy, and all I'm doing is just changing the sign on the original, right? So my 2, 2 changes where my x now becomes negative 2, 2. And so that point is going to go to that point. So it still has a vertex there. And then let's try this other one, right? This 2, negative 2 transforms into, I'm going to take my x, it's going to be negative 2 now. My y stays negative 2. All right, that's going to go right there. Okay, so hopefully we notice this is a reflection on the y-axis, but even if we didn't necessarily notice that, it doesn't matter because the vertices are the same, right? So we could have done those 2 points on the left, and it would have just flipped to the points on the right, so that's going to be fine. All right, so let's check our b here. So let's take our original point, 2, 2, and then I'm going to call it 2 minus 2, and then 2 minus 2. So really that's just going to end up being 0, 0. So that's shifting down 2 and then over to the left 2. So that is definitely not the same vertex. So let's see if we've got the same thing working here. So now we're going to subtract 2 minus 2, and then negative 2 minus 2. So that's going to be 0, negative 4. Yeah, that's going to move down here. So this is actually a translation or a slide. And as you can tell, this obviously does not keep the same vertices. I'm moving those two down. This one would go right here, and that one would go right here. And this would be your new square, which makes it now look like a cube. But that is definitely not a transformation that keeps the same set of vertices. That is a transformation that slides it or translates it. So I'm thinking that's my answer, but let's double check. All right, so I've got 2, 2, but now look at my rule. I need to just flip the signs on both, right? So it needs to be negative 2, negative 2. And so this is going to go all the way right here, right? And so it is going to keep the same. Let's see what happens with, I've got my 2, negative 2. Just flip the signs, it's going to be negative 2, positive 2. And that's going to go right there. All right, so this is a 180-degree rotation, and it is keeping the same vertices. Let's check our last one. Now this one, as you can tell, we're flipping it a little bit, right? So we've got my 2, negative 2. My y becomes my new x, and it becomes negative. And then my x becomes my new y. Okay, so I've got my 2, 2 goes to negative 2, 2. So we've already done that one, but it's not the same as a reflection. So let's see what this next one looks like. 2, negative 2. My y becomes my new x, and becomes the opposite. So that's going to be positive 2. And then my y slides over 2. So this is actually a 90 degrees counterclockwise rotation. And it keeps the same vertices. So my answer here is B. Let's see how we did across the state of Texas. So this was tied for the 18th easiest. You see, we almost had 50% or half of our students get it correct because we had a nice visual here. And even if we don't remember the rules, we can use the graph to work things out. And a lot of students probably recognize that this B definitely did stand out, because take a look at A, C, and D. All you're doing is switching the positions of X or Y and changing the positive to a negative or the negative to a positive. But B definitely stands out as the one that's different because you're simply subtracting from the X to the Y, which means you're going to shift the values. And so this is the one that hopefully we see stands out as a translation. The others can be either reflections or rotations, depending on how you work them out. And that's the one that stands out. For number 22, we are looking at slope-intercept form. This is reporting category 2, TEKS 8.5b. This is a multiple select, so we need 2 correct answers, right? So if we just try to move on by selecting one, it's going to give us the error message. And if we select 2, you'll notice that even though I'm trying, I cannot select a third. So it is impossible to select more than 2. They really want you to select 2. So the hardest part here is to figure out what exactly they're talking about. The value of y is 3 more than twice the opposite of x. Now that's how it's written out in words. So let me see what this says. Y equals, y is 3 more than, so 3 plus twice, okay, so that's going to be 2 times the opposite of x. So if x is positive, the opposite is going to be negative x. So that's what it looks like. Y is 3 more than twice the opposite of x. But that's typically not how we write things, right? Normally, 2 times negative x, we could just say that's negative 2x. And then, as you can see, we're getting kind of close to slope-intercept form. Let's put our variables first, right? Our constant second. So y equals negative 2x plus 3. That's what it is. That's what it really is, the best way to represent it, but that's very different than what's given to us in words. And so hopefully we're saying, all right, so that's a definite yes right there. So we want that. The problem is now we have to find at least one other representation here, okay? So I'm going to just take a look at my first two, because look, I've got a slope-intercept form, which means I've got my b, or my y-intercept, as positive 3. Okay, so they're both possibilities, but you know what? This is a positive slope. Look at this second choice right here, because it's moving up. So it's definitely not that one. So it could be this one, right? Let me do my rise over run. So I'm going to go down 2 over 1. Yeah, that's negative 2x. Yep, slope-intercept 3. So this one looks good as well. So I'm thinking it's going to be these two. But I do have two tables down below that I need to just show that they're incorrect, right? So let's do the rise over run here, okay? So I'm going to say it's 2 minus 0. I'm going to use those two. And then negative 1 minus 3. So that's going to be 2 over negative 4. That's going to be negative 1/2. Nope, so the slope doesn't work on that one. So let's look at this bottom one now just to eliminate it. So I've got my negative 5 minus 3, right? So let's do the same thing over here. Negative 4 minus 0. So I got negative 8 over negative 4. Close, but that's a positive 2. And I wanted my slope to be a negative 2. So my answer here is going to be that first and third option. Let's see how we did across the state of Texas. So this was the second hardest problem on the test. Using the full credit as ranking there. I'm not necessarily counting partial credit, because partial credit gets 1 point, but I want our students to get both points there. And partial credit means you got 1 correct and 1 incorrect. If I were to guess, right, this is just my own supposition, I think a lot of students grabbed this one right here and were able to run with that because it's the only one that's in slope-intercept form. And you know, once you kind of look at that statement at the beginning a few times, it does kind of start to look like that positive 3 twice negative x, or the opposite of x. But I think a lot of students struggle with how to find the next one, right? So how do you take your slope-intercept form, and how do you verify that is being accurately represented either on your graph, or, as you can see, a little bit more difficult, especially for the visual learners, probably this table as well. The fact that it wasn't on one of these tables made it difficult because you had to kind of work everything out. So this means that our students need many opportunities to, first off, figure out what this is, right? So practice taking a slope-intercept form and writing it out in words, because you're going to notice it's going to look a little bit different. So that took a little bit of translation. Then taking that slope-intercept form and translating it into some graphs or into some tables as well for practice. For number 23, we are looking at TEKS 8.7c. This is reporting category 3 using the Pythagorean theorem, which is a readiness standard. And so we have a parallelogram here, and we need to prove that it is a rectangle. Well, it looks like a rectangle, but how do we prove it? Well, what does that mean to be a parallelogram? Well, this parallelogram is actually a technical definition. It means we have a quadrilateral, right? So that's going to be 4-sided shape, and it's going to have 2 sets of parallel lines. So that's what a parallelogram is. But within that big section of what a parallelogram is, right, you've got parallelograms like this, you've got rectangles, you've got rhombuses, you've got squares. So how do we prove that it's a rectangle? Where there's a subset here of parallelograms, and those are rectangles. They are parallelograms, but they have 4 right angles. So we need to prove that we've got 4 right angles, but since we've got parallel lines, that means that our opposite angles are equal. So really, we just need to prove that one of these angles is right. And if that's the case, then we can prove that the rest are Also right angles, because we know that these side lengths are all the same. So let's just take a look at this one right here, because I see a dotted line that is connecting the two diagonals. And hopefully at this point of the problem we're thinking, you know what, that looks like a right triangle. When I see right triangles, this is what I think. I think of the Pythagorean theorem. Let's go all the way down to the bottom here. You see that a squared plus b squared equals c squared. So that's what we should be thinking right now. The Pythagorean theorem, a squared plus b squared equals c squared, because we got that rectangle here. So let's call that a, let's call that b. Remember, c is always across from the right angle, right? That's the hypotenuse. But it's not just a plus b equals c, okay? So it's like if this were a square, and this were a square, and if you add the area of these two squares, you would get the area of this huge square, which kind of goes off the screen a little bit there. That's really what we're looking at. So we'd have to find the squares of each of these, right? So 15 squared plus b squared, which we'll call that 8 squared, right? Equals, I have it c squared, but I notice they're not using c, they're using tq. All right, so let's do tq squared. And so yeah, 15 squared plus 8 squared equals tq squared. They kind of rearranged it, but it looks like our answer here is D. Let's see how we did across the state of Texas. So this was tied for the 10th easiest. As you can see, we've got 61% getting it correct here. And this 16 and 15, obviously this A has the a squared and the b squared and the c squared. It just uses the wrong operation. And then b is just pretty obvious. You're going to take the two numbers, but you're not going to square them. That's the problem with both b and c, is that you don't square them. So this is the Pythagorean theorem, but it's not overt. And so this is where we need to provide our students with opportunities to see, how does a squared plus b squared equals c squared, the Pythagorean theorem, how does that come into life here in this situation? Because it's really a parallelogram that we're trying to prove is a rectangle, so that's an application of the Pythagorean theorem. And so sometimes it's those opportunities that we need to provide our students so they can see how it's used in various situations. For number 24, we are looking at slope and y-intercept. This is a reporting category 2 readiness standard 8.4c. And so we have a basic function graphed here, but take a look at our answer here. This is called the equation editor. Even though there are 3 boxes we have to fill in, this is only worth 1 point. We either get it all the way correct or all the way incorrect. So let's find the slope here. We've got a few different options. If I want to look at my reference material, we can see that on linear functions, right, it's that third equation there, slope of a line, m equals, and then change of y over change of x. So we can calculate that using actual numbers, which I'll do. We can also just calculate that using the graph. Let me show you how we can do it with numbers, though. So let's make this our x sub 1, our y sub 1, our x sub 2, and our y sub 2. If you wanted to flip those, you'll get the exact same answer. So here's our equation. What we're going to do is we're just going to substitute in these values. So my y sub 2 is negative 1 minus my y sub 1, negative 3. So that's going to end up being 2 negatives making a positive. My x sub 2 is 4 minus, and then I've got my negative 4. So 2 negatives make a positive, right? So that's going to end up being positive 2 over positive 8, which is 1/4. Also, if you wanted to just use the graph, right, you can say, well, what's the change in y? I'm going to go up 2, and then over 1, 2, 3, 4, 5, 6, 7, 8. Over 8. That's the 2/8 or the 1/4. Now, how do we fill that in? Well, we've got a few different options here. If you want, you can just type in the graph, or type in using the equation editor, you can type in the fraction, but you actually have to hit that fraction button first. So down at the very bottom right, I have to hit the fraction button first. You see the fraction bar showing up. You put the numerator in first. So I'm going to hit that 2. And then what I'm going to do is I'm going to hit that gray bar on the bottom to get the denominator going on, and I'll hit that 8. So 2/8 works. If you want to do the simplified version, right, you hit the fraction bar, you can hit the 1. You see it's a little bit finicky there. Then you have to hit the bottom and hit the 1/4. That's also correct answer. That is also 0.25. So if you wanted to put in the decimal there, that is also correct. And you see how sometimes it's a little bit tricky to get that last one in there. Any three of these answers are going to work. 1/4, 2/8, 0.25. So that's the difficult part, so to speak. Now we need the y-intercept. And that y-intercept is going to be right where it crosses the y-axis. Normally we would just call that -2, but we need the full x and y coordinates. So it's x of 0, y of -2, because whenever it's the y-intercept, the x is always 0. So that's a little bit easier. 0, hit that negative button underneath the 0, and then the 2. So that is our answer. Let's see how we did across the state of Texas. So, as you can see here, this was tied for the 4th most difficult because we only had 28% of our students get it correct. Remember, this is just a 1-point problem. So they either get all 3 boxes correct or they get 0 points. I think there were going to be many options for students to enter into the slope, but you saw that sometimes the actual equation editor itself was a little bit tricky to use. You first had to hit this fraction button to get this to show up, then you had to hit the numerator, right? And then you had to hit the little gray box that's blinking down here in order to activate the denominator. If you didn't do that, right, if we just hit the 2 8s, if we wanted to do that, right, that 2 and then the fraction, then it looks like a mixed number. And then you got all kinds of problems because you can't make it look the way you want to. So you actually have to hit that bar, that fraction bar first. I think that's going to cause some issues for students. Also, just having it not stay, that cursor stay there. I think there's many issues in this particular problem, and I think a lot of it came with the actual test itself. So as many opportunities as teachers can get to let students play with the equation editor and get used to how finicky it is, that's going to help them stick with this and answer this correctly. Number 25, we are looking at surface area. This is TEKS 8.7b, a readiness standard in reporting category 3. So we have a box that's in the shape of a square prism, and as you can see, we're looking for the total surface area. So let's open up our reference material first to figure out what total surface area looks like for a prism. You see at the very bottom of the screen, S equals pH plus 2b. So let's write that first. S equals pH plus 2b. Now we still need to interpret that. And we have a box in the shape of a square prism. So let's do this. I'm just going to draw a square prism. Might not be perfect, but it's going to give us at least something visual that we can look at. So what do we know about this? The height of the box is 8 inches, so I'm going to call this 8 inches right here. And then the area of the square base there is 16 square inches, right? So that's my area. So the total surface area means I need this P. Okay, so that's the perimeter. This means the perimeter of the base. I don't know the perimeter of the base. I know the area of the base, but I know it's a square base. So if that's a square base, right, it's going to be the side times the side equals 16. So what times what makes 16? That's going to be 4. All right, so if my side is 4 and it's a square, 4, 8, 12, 16, the P is actually going to equal 16. It just happens to be 16 inches as the perimeter, 16 square inches is the area, but rarely are the perimeter and the area going to be the same. So that's 16. My H is my height. They did give that to me. That's 8 inches. And then plus 2b, this is the area of the base, and that's what they already gave me. They gave me that 16. So it looks like S is going to equal 16 times 8 plus 2 times 16, because that's what they already gave me. All right, that seems pretty simple. Let's go ahead and get our calculators out. Let's just multiply that. We're going to do 16 times 8. And then we're going to do 2 times 16. Add those two together. 160. And our answer is going to be A. Let's see how we did across the state of Texas. So this was the 8th most difficult. Look, our correct answer is A, and that wasn't even the most chosen. B actually had a few more students choose that, 128. Now, where do we get 128 from? Well, let's say we just completely miss this, or just don't really feel like trying to find the total surface area. We know how to find volume. That's base times height. Look what they give us, the height and the base. So what would happen if we multiply 16 times 8? Well, guess what you would find? 128 inches. The problem is it's inches cubed, not inches squared. So the 128 is the volume, but we don't need that. We need the total surface area. So I'm not sure what the confusion there was, except for possibly we started looking at this and they give you the area. They don't even give you any side lengths. You had to derive the side lengths here from the area being a square in order to find the perimeter. So that was a little bit difficult. So that's going to be an area of opportunity here, is helping students use this formula for total surface area, but then not giving them everything explicitly, like the perimeter or the height. Maybe they have to derive that, solve that from another measurement, or possibly we can have students practice by taking a prism like this and then find the total surface area, and then find the lateral surface area, and then find the volume and see how those measurements differ. Number 26, we are looking at slope as unit rate. This is reporting category 2, TEKS 8.4b, a readiness standard. And so we have a bus traveling 25 miles in 30 minutes. We need to find a graph that has a slope that best represents that miles per minute, right? And they give you the exact ratio they're looking for. Miles per minute. So miles over minute. So miles per minute. And they've got 25 miles over 30 minutes. They give that to you in that form. And our slope here, right, take a look, our minutes is going to be on the x-axis. And our distance is going to be, or miles, is going to be on the y-axis. And, right, we know that our slope equals the change in y over the change in x, right? So they're all proportional. They're all starting at the origin. So look at those numbers they give us, 25 and 30. Well, let's just plot that point, right? Let's see, my x value needs to be 30, so you do need to invert that. My y value is 25. Let's see if we can find that slope on any of these graphs here. So my x of 30, my y of 25 is going to be right around there, and you see that A is a little bit too high, right? Because that 25, 30 is that reduces to 5/6, and A looks like it's more proportional. It's just a slope of 1. So we're close on A, but let's just scroll this down. See what we have. That's where it would be on B, and as you can see, it looks like they flipped that, right? It looks like this B is that 30 over 25. So they inverted that. Let's see what we have here for C, and look, it's exactly perfect. X of 30, Y of C, and we can't get that dot to go down there, but as you can see, it's going to be much too steep for D, so our answer here is C. Let's see how we did across the state of Texas. This was the 4th easiest. 67% of our students were able to get C. You notice that the most chosen incorrect answer was this B, and what this was is they had kind of inverted, right? They took an X of 25 and a Y of 30. It actually plots right there. So it looks very similar, but obviously we were wanting to flip that to the 30, to the 25. But they didn't get a lot of students, right? So that's a pretty good representation. Two-thirds of our student were able to get that, and so we just need some extra practice. This was pretty easy because you could have taken this 30 and this 25 and it was on the graph. Sometimes you won't get that, so you would have to end up, right? You'd have to end up simplifying that into that 6/5 or that 5/6 or whatever we're looking for. Sometimes it's not exactly going to be the 25 and the 30, but in this case it was.
For number 27, we are looking at volume. This is a readiness standard, TEKS 8.7a in reporting category 3. So we have a cone here. We simply need to find the volume. So let's open up our reference materials. And we are going to see that volume right there. We've got 3 different rows to choose from. And we need to expand it out here. There we go. So volume of a cone is going to be 1/3 base times height. We see that second to last row. So let's write that down. 1/3 base times height. And we need to interpret that a little bit here. This B actually means the area of the base. So our base is a circle right there. So how do we find the area of a circle? Well, we can open up our reference materials again, but really that's going to be pi r squared. Okay, so if I wanted to rewrite this, I could say 1/3 pi r squared times height, because I just kind of substituted in that pi r squared for the base. That's what this h is, right? It's my height. Now here's the tricky part. I've got 2 different measurements. I've got this 12 and I've got this 13. This is actually my slant height. So it's the height of that curved face. I don't need that. I'm looking from the vertex to the center of the base. So I need this 12. So this is what I'm looking at here. V equals 1/3 times pi r squared. So that's 5 squared times my height, that's 12. I can simplify this a little bit. So 5 squared, that's going to make 25, and I want to do this 1/3 times 12, so that's going to be 1/3 times 12, that's 12/3, that's just 4. 4 times pi, and then my 5 squared is 25. 4 times 5 is 100 times pi. I know that pi equals 3.1415, so if I multiply by 100, I'll just move the decimal over twice. It looks like it's going to be 314.15, or I've got that 314.2. Looks like they're just rounding to the 10th place. My answer is A. Let's see how we did across the state of Texas. So this was actually towards the middle. This was the 14th easiest. You see we got 54% of our students getting it correct. So what made it not so easy? Well, take a look at our second most chosen answer, this 340.3. Where does that come from? Well, remember, right, we've got this 1/3 base times height. That's our basic volume. Well, what is the height? If you were to substitute in this 13, the slant height, which is incorrect, we should use that 12, that's going to get you this right here. So there's a little bit of an opportunity for students to practice with extraneous information, recognizing the difference between the height and the slant height and making sure we're choosing the right one. For number 28, we are looking at TEKS 8.5D. This is a reporting category for a readiness standard about trend lines. So we have an organization here publishing pamphlets. We have a scatter plot, so we need to create a trend line. And we're looking for a prediction for the 10-page pamphlet. So I'm going to have to be scrolling up and down here. So since I'm going to be drawing on my graph to make that trend line, grab some of these data points, 1500, 2000, 24, and 2700. So what I want to do is I want to see which of these is going to be our best prediction. But I don't want to have to scroll up and down, because once I scroll up and down, I'm going to mess up my drawing there. So 2400 and then 27. All right, so I'm looking for a 10-page right here. So it needs to be on this line right here. I'm just going to kind of draw it up like this. All right, and so if I'm drawing a trend line, I'm wanting to kind of split the difference if I'm looking for clusters, right? So in between these two right there, got a nice set of 3. I want to go straight in the middle there, maybe a little bit below that one. And so I'm going to just, as much as possible, draw a line that kind of extends. And you notice I tried to draw it straight. I'm off the graph. So let's see where I ended up. I ended up way up there. So that's 2200, but I'm off the graph. So let's plot some of these points here. So they've got 1500. Remember, this is my 10 line, so that's right down there. That's not going to work. 2000 is right there. That's not going to work. Where's 2400? Well, if I go one line above I'm going to try to make it the same distance. That's my 24. So that looks pretty close. My 27 would have to be another line up above like this. That's going to make that 26, right? Because there's my 24. And then my 27 is going to be even above that. So that's going to be too high. So it does look like it is going to be that 2400. This was my original, and the 24 is going to be kind of right there. So that's going to be, my answer is going to be C. Let's see how we did across the state of Texas. So this was tied for the 19th easiest, which means it's right in the middle of the pack. Just a hair under 50%, 48% got it correct. So what was so interesting about that 2000? Right, so remember, here's our trend line. So we're kind of going up like this, right? We're off the graph. 2000 is right there, okay? So that's not going to work. But what happens if you choose the 8 right there, right? 8 is that first blank spot, right? So if we're not really paying attention to the 10 page, right, that 2000 makes a whole lot of sense. So there's a little bit of opportunity for our students to make sure we read all the parts of the problem, because obviously we're not looking for 8 pages, even though that is the first blank spot. We are looking for 10 pages, and that's our answer, C. Number 29, we are modeling slope-intercept form. This is TEKS 8.5i, a readiness standard in reporting category 2. So we have a graph. We simply need to write an equation here. Notice it is drag and drop. So there's 2 points there, and I can't use a number more than once. So if we try to use just one, it is going to say you have messed up. You've only used 1 point. So let's see if we can get both of these correct here. So what are we doing with this slope-intercept form? Hopefully you recognize, right, slope of a line. We got the slope-intercept form that y equals mx plus b, the very first equation. Those are the 2 missing pieces. We have y equals blank x plus blank. All right, so let's open this up here. And you see the blank x plus blank. So that's really what we're looking for, is the m, right? I need the mx plus b. Well, we could do the easy one first. B, hopefully we know, is the y-intercept. So where does this cross the y-axis? Looks like it's crossing right there at 6. It's a positive 6. So that's going to be pretty simple. Let's grab our 6, hit that easy button. We're going to hit that 6 really quick. Now the slope is going to be a little bit more tricky, but I can tell you one thing. It is moving up from left to right. It's fairly steep, so it's going to be positive. And I think if we're looking at positive, take a look. I've got 3 answers I could immediately get rid of. So I've got 2 left, and I'm thinking it's going to be the 3/2 just because that's the larger one, right? The 2/3 is going to be a little bit shallower like this. But how do we know for sure? Well, we need 2 points. And so we can take these 2 points right here. So this is going to be 0, 6. And then let's use this x-intercept right here. That's going to be -4, 0. And let's use those in our slope, right? That m equals change in y over change in x. So I'm going to make this my my x sub 1 and my y sub 1, and I'll make this my x sub 2, y sub 2. All right, so that's going to be 6 minus 0 over my x sub 2 is 0 minus, and then I've got -4. All right, so that's going to be 6 over 4, so that is going to be 3/2. And so just as we thought, y equals 3/2 x plus 6 is our answer. Let's see how we did across the state of Texas. So this was the 7th most difficult problem. Take a look. We only have 30%, not even 1 out of every 3 students that could get both of these boxes correct. And even then, we had 2 points there. Only 33 extra students, 33% extra, could get just 1 out of these 2. And obviously this y-intercept is just staring right at you. So this is a little bit concerning that we had such a low amount of students be able to get this. Hopefully we're seeing that this y-intercept is pretty obvious. So we should have at least had a lot more students get at least that 1 point, because take a look at this. 36% of our students, more than a third, couldn't even figure out that y-intercept. So this means we need a little bit of extra work with understanding what is the basis of the slope-intercept form. Why do we call it slope-intercept? Well, that slope is the m, but the intercept is the y-intercept. And if you've got a visual graph for you right here, all you have to do is look to see where the graph is crossed on the y-axis, where that line crosses. And then obviously, this being a drag and drop, there is a lot more room for error. But even as I showed you, if you know that this is a positive slope because it's moving up from left to right, you could have eliminated so many of these options. So a lot of extra work opportunities for students to just take a basic graph, just any graph here, and just say, give me the slope-intercept form, and just take it directly from the graph. No points are given to you. And see how students practice looking at the y-intercept, and then using the y-intercept and hopefully the x-intercept, as long as they're both integers, to find the slope. For number 30, we are ordering numbers. This is TEKS 8.2D, reporting category 2, a readiness standard. We simply need to put these in order from least to greatest. So let's make sure we underline that. That's going to be very important, right? So we want the smallest to the largest. And we've just got these four numbers here. And let's get our calculator out. No point eyeballing this. Let's change everything to a decimal, because if we could change everything to a decimal, then we can simply figure out which one is the smallest and which one is the largest. All right, so we are going to go ahead and start with, let's just use A, right? So what I'm going to do is I'm going to just use A as kind of my order there. And I'm just going to take the four terms from A. Now, obviously, A might not be it, but I'm going to use that as my starting point. So negative 4/3, right, is going to be, let's just get, that's negative 1.3 repeating. I've got 0.43, it's negative, so that's already in line there. Then I need square root of 3 and 5/2. This might work because you see I've got the two negatives on the left, so I definitely need the two negatives on the left. Let's check the square root of 3. I'm going to hit my second, and then I'm going to hit that x squared to get the square root. It's going to be 1 point something, 1.7.73. And then I've got my 5/2. Well, that's just going to be 2.5. So actually A is correct. Look at that. They give it to me from least to greatest. We know that it can't be D, right? Because it's got the two positives over on the left. And obviously this is larger than this right here. And the problem with C looks pretty good. They just flip-flop these two. So yeah, my answer is A. Let's see how we did across the state of Texas. So as you can imagine, this was the fifth easiest. We had over half of our students get it correct. And here's the interesting thing. Almost a third got this incorrect answer B here. And you see it's exactly identical, except for those two right there. And so it seems like we probably had some students just kind of eyeball it, and just rather than getting out the calculator thinking, oh, negative 4/3, right, that's going to be a little bit bigger. But if you put it into decimal form, right, you see that's a little bit bigger. And then they need to understand that the larger the number is, if it's negative, the less it is. So issues here could have been that maybe they didn't necessarily translate it into decimal, or maybe there's a misunderstanding with positive and negative, and maybe students don't know that the larger the number is as negative, the farther away it is from 0, which means the smaller it is. For number 31, we are describing the volume of a cylinder. This is TEKS 8.6a in reporting category 3. So we have just this descriptive statement stating the volume of a cylinder is 87.35 cubic inches. They give us the radius. So we need to find an equation used to find h, the height. All right, so let's open up our reference material because we don't need to guess what the volume of a cylinder needs to use. All right, we've got that V equals BH. All right, so we can start with that. And then we are going to need, on top of that, a little bit about the area, but let's start with that, right? So V equals BH. Volume equals base times height. Now, this is a cylinder, right? So let's draw a cylinder here just so we can visually represent it. All right, so volume is going to be the base. Now, here's the thing. It's the area of the base. So this is the B, but that's the area of the base. And that base happens to be a circle. So we have to go back to the reference materials if we can't remember. And we need to find the area of a circle. We see that's A equals pi r squared. So I'm going to substitute this B for pi r squared, because that's the area of the base, since the base is a circle. And then I've got my height. Okay, so now I've got a usable formula, right? To find the volume, I need the pi, right, which is just that 3.14. We've got the radius I need squared and the height. Okay, so what information do they give me? The volume is 87.3. Okay, so V equals 87.35. So I'm going to put that right here. 87.35 equals pi is pi. Radius is 5.17. So this is going to be 5.17 squared. And then they don't give us the height. We're looking for the height. So how do we isolate this variable? Well, this variable, right, is being multiplied by pi and by 5.17 squared. So we need to use our properties of operations, right, and we need to think inverse operations. So if it's being multiplied, pi times 5.17 squared times height, I need to divide, because that's the inverse operation, by pi and 5.17 squared. I don't need to actually simplify it. Look at our answers. We don't need to actually figure out what the number is. We just need to represent it. Now, why did I do that? Well, when you divide 2 by 2, that equals 1. When you divide 4 by 4, that just equals 1. Anything times 1 is itself. So basically, it eliminates that number, so that pi is going to divide the pi and get rid of it. The 5.17 squared is going to divide the 5.17 squared and get rid of it, and that's just going to leave me h over here. But the properties of operation state that whatever you do to one side of the equation, you have to do to the other side. So since I divided the other side by pi times 5.17 squared, I need to do the same thing over here. And so that's going to get me my answer right there, and we see that right here on D. I've got the 87.35, and it's divided by pi times 5.17 squared. So D is my answer. Let's see how we did across the state of Texas. So this is the 10th most difficult question on the entire test. You see, we barely got over 1/3 of our students getting it correct. And take a look at the distribution of our answer choices here. It looks an awful lot like we are just guessing. And so you see almost 25% for A and C. Some students worked it out, and that's why we're a little bit lopsided from B to D. But ultimately, that didn't look like our students had a really clear idea of what to do there. I'm doubting that the issue is setting up this volume equals base times height. This volume is pretty standard, what we do in 8th grade. Understanding that we need to make it look like this. I'm thinking the issue might have been representing it with the properties of operations. So really calling out the properties of operations is going to be something that we need to provide our students opportunities for, so they understand how they can isolate a variable and represent it as well. For number 32, we are looking at slope and y-intercept. This is a readiness standard, TEKS 8.4c, in reporting category 2. So we have to find the slope and the y-intercept here to help us understand this problem, but there's no graph. So take a look here. Josh is saving money to buy a computer. He has an initial amount that he has saved into a jar. So this initial amount, right, if we were to graph it, it's going to be something like this. We're assuming that it's going to increase each month, right, because he's saving. So that initial amount, that's also what we would call the y-intercept. Where does it start, right? If you're 0, right there, your x is going to be the months. and then your y value, right, is going to be your money. Okay, so he starts with something. He doesn't start at 0. So this is the y-intercept. In each month, he puts an additional amount of money. The table shows the linear relationship. Okay, so it's a linear relationship. That means, you notice how I drew a straight line? It means it's the same amount each month, right? He's not putting in $20 and then 5 and then 30 and then kind of waving up like this. It's a linear relationship. So we can take a look at here. We can kind of find the pattern, right? So if you go up 2 months, so this is a plus 2, and this is a plus 60, right? So my slope is going to be my change in y over the change in x, right? So that's going to be 60 over 2, so it looks like $30 a month. Let's see if it holds true here. This is plus 4, right? So this is going to be plus 120, so that's 120 over 4. Yep, that equals 30. There's the linear relationship. This is another plus 4, so this should be another plus 120, which it is. All right, so we know our slope or our monthly amount is $30. Now, let's work backwards. Let's see how much money that he had originally in there. Okay, so I know what a plus 4 is. That's 120. So I'm going to go down 4 to get me down to 1 month, right? So that's going to be minus 120. So that's going to be, right, the 105. 225 minus the 120 is going to be 105. Then I just need to get just minus one more. Remember, it's a $30 a month. So it looks like that's going to be 75. So the initial amount right there is going to be that $75. So it took a little bit of work. You can't just visually look at a graph. But we found the initial amount, $75, the monthly amount, $30. Let's take a look at our answer choices, right? This is incorrect. This looks good. And then both of these are incorrect, right? We needed it to be $30 a month. So our answer here is B. Let's see how we did across the state of Texas. So this was the 10th most difficult problem, right? Obviously, when we have to deal with a table rather than a graph, it makes it a little bit more difficult. Only 2 out of 5 students could get it correct. Now, what was so interesting about C that it got us correct? Because $45 a month, right? That's obviously we had that, the 60, right? And then we had the 120 and the 120. So it's not as if they got that 45 from there. What if we're not really sure how to find the amount of money? Well, what if you just take the total amount in the jar, 225, divided by the number of months? You're going to get 45, which would work if it were proportional, if it started at the origin. But we already said he had an initial amount, so you can't just divide that. So these students that chose this really didn't understand that y-intercept having an initial amount means that you can't do this. You can only do that if it's a proportional relationship and it goes through the origin. So we need to have students practice a little bit more about what it means, understanding what it means to find an initial amount, and using other methods such as looking at the change in y over the change in x, rather than dividing a y and an x to find the rate when you have a linear relationship that is not proportional. For number 33, we are looking at dilation representations. This is a readiness standard. It takes 8.3c in reporting category 3. So we have a table simply describing 2 dilations with the center of the dilation at the origin. We need to describe the rules. This is a drag and drop here. And you notice that you can only use each number once. And if we try to move on without answering both, it is going to give us a warning because it is a 2-point question, one for each that we get correct. So let's take a look at our dilations here. What do we know about them? Well, dilations can be represented algebraically like this: xy, and then you have this kx, and then ky, and that k is your scale factor. And if we look at that word scale factor, it gives us a big clue here. Because a factor, when we think of factors, we should think of multiplying, right? So 3 times 4 equals 12. The 3 and the 4 are the factors, right? The 12 is the product. So when we see the word factor, we should think multiply, which means we're not using those. Dilations have a scale factor, and a scale factor means we're multiplication. What are these two options over here? Well, these two, I'll put them in blue. These are going to be translations, slides, right? So what we're doing here is we're sliding it up and to the right because it's a +2 and +2. We're sliding this one down and to the left because it's a -1/2, -1/2. That's what we're doing with those two. So we're just stuck with these two, and once we get these two, it seems like it's going to be pretty easy, right? It's dilated by a scale factor of 1/2, so right there, and then scale factor of 2, you see that 2xy. So once we put together this word factor, and we think, oh, that means multiplication, that really just gives us these two options. We just match up the numbers. So those are the correct answers, the correct rules. Let's see how we did across the state of Texas. So this was the 13th easiest. As you can probably guess, most of our students got at least 1 point, right? So this is 2 points, 1 point for the partial credit, no points. But you put this together, we're looking over 80%. So it would have been nicer to get this a little bit higher. But really the idea here is to just focus in on this word scale factor, right? And realizing that factor leads to multiplication, right? And so dilation means we're multiplying it by either a whole number to make it grow or a decimal to make it shrink, which then just leaves us with these two options.
For number 34, we are identifying functions. This is TEKS 8.5G, a readiness standard in reporting category 2. And we have mappings here. So if we know what a function is, then we are good to go. And that's going to be easy. If we do not know the definition of a function, it's going to make it a little bit more difficult here. So what is a function? A function is a function when each input, right, and our inputs are typically our x's, leads to just one output. So we're looking to see, does each x lead to one y? And we're going to find 3 that don't, right? So look at A here. A, I've got the 0.25 goes to 0.50, but look at this 0.35. It goes to 2. It goes to that 0.70 and the 1.10. It's fine if 2 different x's lead to the same y, but each x can only be mapped with one y. So A is not it. The issue is that 0.35. So let's check B. Right off the bat, we've got issues. Look at that 20. That 20, right, goes to both the 5 and the 20. So that's not going to work. And look at C, obviously, right? Not going to work. 0 goes to -5, 0 goes to -9. So let's look at D, because I hope that's it. So even though there's only 2 y's, as you can tell, each x only leads to one of them. So the fact that there's only one arrow off of each x, even though they all point to the 1.0, is totally fine. Each x leads to one y. Our answer is D. Let's see how we did across the state of Texas. So this was tied for the 17th easiest. A little bit over half of the students were able to get it correct. This was just a difficult one because typically when we're looking at mappings, what you'll see is 4 different numbers here. And typically the correct answer is, each of these goes to a separate one like this. Sometimes they're not as obvious as going straight across. They might crisscross a little bit, but typically there's 4 x's and 4 y's. And that's what students are used to. So the fact that the correct answer is the one that did not have 4 x's and 4 y's means that we really need to lean into this definition of a function. It's not that each x goes to a different y, but that each x only goes to one y. That's the difference. Number 35, we are looking at dilations and measurements. This is standard 8.10D in reporting category 3. So we have a polygon, an area of 27 square meters, and polygon A is dilated by a scale factor of 3. Polygon B, okay, so I don't know what these polygons are, but 27 are square meters. So, you know what? Let's just pretend that it's going to be a rectangle, because they didn't tell us it's not going to be a rectangle, right? So I'm just going to draw something that kind of looks like this. I'm not going to necessarily draw it to scale, but we need a visual representation. All right, so 27 are square meters. Okay, so let's make this R. Put that drawback on. R and 27. Okay, so area equals, right, base times height. So that's going to equal 27R. There we go. Now polygon A is dilated by a scale factor of 3 to create polygon B. Okay, so what that means is I'm going to make the base here 3 times as big, right? So that's not to scale, but an extra 27 and an extra 27, and I'm going to make this R, right, 3 times as long. And assuming that was to scale, you would get something how much bigger? Well, you notice I multiplied this R times 3, then I multiplied this 27 times 3. So what I would need to do to find the area would be that 27 times the R, right, base times height, times 3 squared, or 3 times 3, because I multiplied both sides by that scale factor of 3. So really that's going to be 27 times 9. It's still going to be R. We're not going to get away from that R. So whatever that 27 times 9 is. So let's open up our calculator. See what 27 times 9 is. 243. Okay, so 243R is going to be our answer because I had to multiply both the base and the height by my scale factor of 3. So my answer is A. Let's see how we did across the state of Texas. Well, we finally found it. This is the #1 most difficult question on the entire test. Look, this wasn't even the first or the second most chosen. This was the third most chosen option, only 14%. And this is a multiple choice. We cannot blame this on drag and drop or equation editor, anything like that. Okay, so what was so enticing about that 81? Well, look at this word factor of 3, 27. If I'm just taking my words, 27 times 3, there you go. There's your 81, which might work if we were looking at a straight line, right? If we're looking at the length of a line, right, we're going to do 27R, and we want to multiply by a scale factor of 3. Absolutely, just multiply by 3. Obviously, the difficulty here comes from the fact that we've got a polygon, right? So a polygon, and they didn't tell us what it was, so I just chose my rectangle here. But once we saw that we had this, the base and the height, we knew that we were dealing with square meters. And so we needed to deal with both the base and the height. Now, some of us chose this B, this 9R, and that's most likely just ignoring this right here and just taking that 3, right, and just taking the 3 and the 3 and multiplying that to get the 9. But that's obviously ignoring the 27R square meters. So this one was very difficult because you had to have a pretty good visual representation and realize that both the base and the height needed to be multiplied by 3, which means you're basically multiplying it by 3 squared, or 9. For number 36, we are working with one variable equations. This is a readiness standard, TEKS 8.8C in reporting category 2. So it looks pretty simple. We've just got a few sentences here. Let's see if we can turn this into an equation. Looks like we are going to be solving for x, so we'll need to figure that out. So Jessica baked 72 cookies and sold x. All right, so I'm going to put Jessica right here, and baked 72, sold x. So that's going to be minus x. Okay, Max baked 36 and sold, it's minus half as many as Jessica did. Okay, that's kind of confusing. I got the half as many cookies as Jessica did. Well, what did Jessica sell? Jessica sold x. So I guess it's half x minus 1/2 x. So I've got two different expressions. How many cookies did Jessica sell if they each had the same number of cookies left over? Okay, so if I said that equals leftover and that equals leftover because it's the same amount, right now I can substitute in this right here and make these two equations equal each other because they both equal that leftover. So I'm going to substitute in 36 minus 1/2 for that leftover over there, and this is what we're going to get. We're going to get, change colors here, 72 minus x equals 36 minus 1/2 x. So that's quite a bit of work just to set up the equation. Now I want to make the x's positive, so let me add x to both sides. But you see how that's going to be kind of weird, right? I'm going to add this x. That's going to obviously cancel each other out. I'm just going to get 72 right there. I'm going to get 36. I've got a minus 1/2 and then a plus x. Right, so x minus 1/2, that's going to equal a plus 1/2. So I don't even have a full x yet, which is what I need. Let me get rid of this 36 next. I'm going to subtract that from both sides. That's going to give me 36 equals 1/2 x. So I'm close, but I can't do anything with that. So I need to multiply both sides by 2. Because if I do that, 2 is the reciprocal of 1/2. 1/2 times 2 is 1. That cancels out. So that's going to say x equals 72. Would have been a lot easier if they just told us Jessica baked 72 and sold all of them, because that's basically what happened, and Max baked 36 and sold all of them. But they made us work it out. Our answer is 72. Let's see how we did across the state of Texas. This was the third most difficult problem on the entire test. As you can see, we only had 1 out of 4 students get this correct. If you take a look at these answer distribution, really looks an awful lot like guessing. And even when we weren't guessing, right, some students chose B a little bit more than they chose C. Obviously, the most chosen answer is incorrect, that 36. Well, how did we get that 36? Right, well, remember, when we did all of our work, right, we got down to 36 equals that 1/2 x. So maybe students stopped there and they just saw that, right? Maybe students didn't even set up the problem because that was kind of difficult setting up the problem. And we just saw this sold half as many as Jessica, and half of 72 is that 36. Either way, this problem had many difficulties. First, trying to create the actual equation from the words. So that's a challenge in itself, is taking a verbal description or written description and turning that into an equation. And then I think that second layer of difficulty was what happens when you get the x on one side and you still have half an x left over, right? And so it's 2 steps, right? You had to add the x, and then you ended up having to multiply it all by 2 to get rid of that 1/2. So 2 different steps to isolating that x to where you have just a single positive x. That also added a layer of difficulty and would be a good practice point for students. Number 37, we are calculating interest. This is TEKS 8.12D, a readiness standard in reporting category 4. So we have a business owner opening up a new investment account. So we have a principal deposit there of $10,000, and we see that it is going to be compounded annually rather than maintaining simple interest. So that's going to be important. We have our interest rate at 2.5%. All right, so this is a drag and drop, right? So we've got 2 different choices here, and if we just grab 1, try to move on, it is going to give us that error message. So we want to make sure that we fill in both. Let's open up our reference materials to see what our compound interest is. You see it at the very bottom. So we will be using that right there, that A equals P 1 plus R to the T power. All right, so let's use this first one here. And so the P is going to be my principal. It's the initial deposit. There's no additional deposits or withdrawals, which means that our principal stays the same. It's going to be 1 plus my R. So that's my R, but I'm not going to add the percent. I need to change that into a decimal. Right, so you can either divide or move it over 2 times to the left, 0.025. And then that's just going to be the T for the first time is 1 year, because we're looking at the first year, and then we're looking at the second year. All right, so let's open up our calculator. There we go. So I've got 10,000, and then I'm going to 1 plus 0.025. Now I'm going to take that to the first power, which isn't going to do anything, but I might as well just put it in there. All right, so you see I've got 10,250. Now that's actually not one of the answer choices. Why is it not an answer choice? Because I'm not looking for the amount of balance. I'm looking for the interest, right? So I need to subtract 10,000. That's the initial deposit. That's going to give me my interest. So all that work, and I'm only going to get $250 interest, which isn't too bad. So 250 is that first answer right there. So we're going to grab that. All right, now let's go ahead and get our calculator back open. We're going to do the same thing. All of that except we're going to switch that out for a 2 because we want to see what happens at the end of the second year. Okay, so I'm going to do 10,000. Then 1 plus the 0.025, and then we're going to take it to the second power, or we can just square it, right? Now I've got this 10,506.25. Once again, we need to take away that 10,000. Cross off those first 2 digits. I've got that 506.25 cents. So that is my interest in the end of year 1, year 2. Let's see how we did across the state of Texas. So this was tied for the 4th most difficult problem. You can see we barely got over 1 out of every 4 students to get that correct. Even if we put these 2 together, we're still just barely above 50%. But that's 2 points. We want both points here, not just that 1 point. I think what made this difficult was first we had to find 2 different options. We had drag and drop. So drag and drop increased the number of options. Right, we have 7 different options to choose from. But really, once we found that first A was going to be that 10,250, not finding that answer, I think might have caused some of us to wonder what in the world is going on, and having to realize, oh, I need to take the principal away because I'm just looking for the interest. That's that extra step, because we use the equation, the formula that is given for us for compound interest, and we don't find that answer. That requires students take that extra step of interpreting the problem to realize that we don't want the new balance, which is what the compound interest formula actually solves for. We're simply looking for the interest, which means we need to subtract the principal. Number 38, we are looking at similar proportionality. This is TEKS 8.3a in reporting category 3. So we got 2 quadrilaterals, and it says that they are similar. That's going to be very important for us, because we are looking for a proportion. So what do we know if they are similar? Well, if they are similar, that means that we can represent their sides using a ratio, but we have to make sure that we're lining up the sides with the correct sides. And they are oriented the same way. Sometimes they'll rotate one, makes it super difficult. So let's just take a look at these ratios and let's see what works. Okay, so y over 15. All right, so where's my y? My y is right up here over my 15. Okay, so they took the slant over this this slant right here over that slant right there, which means it would work if they did the same thing on the bigger one, right? The 28 over the 22.5. You have to do it in the same order because that y goes to that 28, the 15 goes to the 22.5, but you can see they reversed it. They correct sides, just wrong order, so we can't do that. So let's look at y over 28. Okay, so now, right, they had the same sides, right? So they had the little, right, or the small to the big, right? So they did that y to the 28 with that's fine. So then this 5, that's the small, would need to go to that x. And you see that 22.5 has nothing to do with it. That's the wrong side. So that 5 would work if it was the x because those are corresponding sides. So it's not A, it's not B. Let's check C. So 20 over 30. Okay, so we've got corresponding bases here. And it's small to big again. So 20 over 30. So I got 5. Let's see, we've got 5 over x. Well, that would be, yeah, that's the small to the big. That looks good because it's the corresponding side from small to big. So C looks okay. Let's check D to make sure it's incorrect. So I got 15 over 20, so we're doing it within the shape itself. That's fine. So small to small, 15 over 20, which means I could do the 22.5 over the 30 because that's matching. And you see they've got that x over the 30. That x does not go with that 15. So D is incorrect. Our answer here is C. And let's see how we did across the state of Texas. So this was tied for 20th most difficult. This is right in the middle of this 40 question test in regards to difficulty. You see we got slightly less than half of our students getting it correct. This just takes a lot of work, a lot of keeping a lot of numbers in mind, and a lot of working memory, what this really taxes. So this just takes lots of practice, and not only just evaluating if it's true or it's untrue, but like I explained it, once you find this first one, right, find what would make it true, and then see if that matches up with the second one, rather than looking at all four and saying, oh, that looks good, that doesn't look good. Take each of these first ones, right, and find what would make it true, and then evaluate that against the other proportion. For number 39, we are representing linear proportional relationships. This is TEKS 8.5C in reporting category 2. So we've got some oranges here. Each orange costs the same amount, so that should be our number one clue that we are dealing with a unit rate. We need to calculate that unit rate because we can represent this as a proportion. So we've got 252. 6 oranges each. They each cost the same amount. So let's figure out the unit rate first, and we'll figure out what exactly they're asking us to do here. So we're going to take our 252, and we are simply going to divide it by 6. And when we can do that, 2.52 divided by 6, we will see, all right, 42 cents each. That makes sense. We've got 0.42 cents for each orange. Now, the total cost is going to take your unit rate, right, and then times how many oranges we have, n oranges. Because if we look at our reference materials there, right, we see that second line, that direct variation, that's really what we're doing since it's proportional. That k, right, is going to be that proportional relationship, that 0.42, that cost per orange. So our answer here is going to be A. Let's see how we did across the state of Texas. As you can imagine, this was on the easier side. This was tied for the 10th easiest. We had 61% of our students get it correct. We had some students pick this B, which really is just taking your total and just using that as the unit rate, which that's obviously not the unit rate. And if you wanted to multiply the two, right, the 252 times the 6, well, you would get your 1512. So we don't need to multiply them. We needed to take our total, and since it is the same amount each, we needed to divide it by the number to get our unit rate. And that's the difficult thing about this particular problem, is recognizing that really the same amount is asking for the unit rate. Because once we did that, the rest seemed to take care of itself. For our 40th and final question, we are looking at lines and angles. This is TEKS 8.8D. Reporting category 3. So we've got 4 pairs of triangles that are similar. And it starts out pretty simple, right? It just says triangle 1 is similar to triangle 2, so we're going to use that little squiggly line, it's called a tilde, to represent similarity. Notice that the angles are the same, even though the side lengths are different lengths. They're proportional, but the angles are the same. But now they start naming the triangles like this, and the order is important. Look at this, UVW. So watch, I'm going to go from that top to the bottom right, over to the left. Same thing for KLM, top, bottom right, over to the left. So the order matters when we are naming these triangles, XYZ. So top to the bottom to the left, to X prime, Y prime, Z prime. Top to the bottom to the left. And so we need to do that same thing here for the final triangle. And so that's what we're looking for. They're all TUV and PRQ, but we need to see which one has the same order for both. All right, so let's see TUV. So that's the top to the bottom right over to the left. And then we've got P, top to the bottom left. See how that goes in the wrong order? So it's not A. Let's try this. TVU, top to the bottom left to the bottom right. And then PQR, top to the bottom right. You see how that goes in different order? It's not that one either. Let's try C. T is top to the bottom right, over to the left, and then PQR, top, bottom right. Okay, that looks good. So I'm thinking it's C. Let's just verify that it's not D. TVU is top to the bottom left, over to the right. Oh, look at that, starts with R. It starts at the wrong spot. Nope, it's not D. It is going to be C, and let's see how we did across the state of Texas. As you can imagine, this was one of the easier questions on the test, 8th easiest, as long as we can recognize that we are looking at the order that these angles are named. That's the difficult thing here, because a lot of times when we're looking at similar triangles, the big piece of learning they're trying to get us to recognize is that the angles are going to be the same, even though the side lengths are proportionally different. But that's not the case here. They just simply wanted us to recognize that we needed to name the triangles in the same order both times. And so that gives us an opportunity for extra practice to not only recognize that similar triangles have identical angles and proportional sides, but they also need to be named in the same order.